Chandigarh. He is working in this area of smart grid and smart metering. He has guided several theses also in this area and is a member of the Smart Grid Forum. So I think his exposition will be a very good experience to all of you. I hand over, because it's already late, I'm handing over the mic to him. Cancel करो.
वो काफी उसमें मटेरियल होगा ना, it will take time. वो वर्ड भी है. प्रेजेंटेशन बनी है, देखिए. हाँ, अभी का डेट अभी का है ना. ये पुराना कोई निकल गया. हाँ, ये ठीक.
Start करो. So आप you speak, sit comfortably and speak. You will.
Good morning, everybody. Before we think about the smart metering, we should first go for the different items like why smart, and then metering. Metering is very common thing that is used for water metering, electricity metering, fluid metering, gas metering, etc., etc. But when this smart grid has come into the picture and its implementation, then to make the compatible device which can be incorporated in the smart grid is the smart metering system. We cannot go for the analog one. So today we have the analog kind of meters in households or in buildings or in industries, etc. So what are the things that we have to think? So new metering and communication system, the smart meter, demand response pricing also. So basically most of the smart meters are incorporated with smart metering. Smart means intelligent. That will be quite friendly with the consumers as well as the supplier, because it will be acting just like intelligent devices like your mobile or laptop or PCs. And so the new metering and the communication system, that is a smart meter, demand response and pricing, these are the main areas. That is the pricing option, demand response. That means on the meter you can have the facility to get how much is the demand. You can enter your demand in the meter. अभी we don't have such a kind of option कि हम अपना demand जो है उसमें enter कर सके. No, that's prepaid is a different feature also. That means your demand, how much electricity do you want, that you can say in advance. And moreover the pricing option, because this is related to basically a smart grid. So a smart grid brief is slightly required before going to this smart metering facility. So that is one of the important thing. That is a smart grid is basically it is bi-directional power and information flow, and it integrates all generation, transmission, distribution and utilization. That means a given consumer is also a generator to supply the electricity in the market, as well as using the electricity, that means consumer is consumer also. So today we don't have such a kind of facility that we can generate the electricity and sell, because you don't have the policies as such. Then transmission distribution investments and modernized communication, sensors, grid design and option, manage outage, energy storage, intermittent resources, and customer side of the metering, in-house devices. These are basically the parts of the this is smart metering, T&D estate investments, modernization communication, sensor transducers, grid design, operation, manage outage, energy storage, intermittent resources, where this intermittent resources means solar and wind power. So customer side of the meter in home devices. This is in brief. That is, this is the brief of the smart grid. The smart grid is featured with all these things. Now the federal policies are not mandatory. States have the discretion about adopting, including smart grid policies in the Energy Policy Act of 2005 and 7. States regulates utility distribution rates, that is generation supply, portfolios and rate design in states without restructuring, approves cost recovery, and establish retained tariff and prices for retail electricity services. Smart grid is primarily a matter for a state level. That means even the center makes certain policies. The state has the discretion because of our policies. The state has its own interference in the policies of the central government. That means it cannot be, they may agree or may not agree to implement in toto. Okay, so that's the one of the important thing that affects the price as well as the features. Features means it's whether it should be installed or it should not be installed. And some companies, they give a particular kind of setup, but other companies, so it will say no, I will not accept this kind of product, I will accept that. So compatibility is also one of the important thing in the smart grid. Just is happening, that is the product should be uniform. Inform means it should have a certain standard. So standards is also one of the important problem in smart grid interfacing. That was one of the, in the event I was there, so it was felt that the standard is one of the important norms. That means this product is compatible with this system, so only this should be used only. So more efficient operation eliminates meter reading and field visit job. So what are the features of this smart grid and smart metering? That is, it is more efficient, enables demand response programs, direct load control, dynamic pricing, enables distributed resources to be integrated into grid operation, improves reliability of service, outage detection and management, improve grid operation and efficiency, integrate renewables like customer sites, the meters, utility operation in home device appliances. So this is the feature of the smart grid. It includes all things. You can see it's more efficient. No need to go to the office. Normally, today to pay your bill, you go to the office. And if you have any problem, you go to the office. But here you don't have to, you can feed your information in the meter itself. And moreover, there is a feature like plug and play. That means just like mobile, when we have to charge it, we just put and get it charged. So in a smart grid, we have the option to get it plug in, and you can get the information from the grid, as well as you can give the information to the grid also about your house. Load and pricing and demand. That's the feature of this one. So enables demand response program, direct load control, dynamic pricing. Dynamic pricing, it's very important. That means every moment the price is going to change, because this integrates the various distributed generations like solar power, then wind power, where it is generated in Arunachal Pradesh or in Chennai or in somewhere remote places. So they are all integrated, and depending upon the weather situation, that is due to the intermittent situation, what happens, that the pricing is going to change, because all the round the solar energy is not constant, even wind energy is also not constant. So as the generation is changing, that's why the price is also changing as per the demand. So these three features are there that gives the dynamic option. That means the rate of the electricity is going to change. Today we have the fixed rates. And enable distributed resources to be distributed is that is solar and wind power and any other sources like bio energy also, and reliability of services and outage detection and management. That means the system is so intelligent that it can say about its outage. That means the system may inform you in advance that this system is going to be out of order. That means it is going to be damaged. So you may replace it. It may request the consumer or some other service provider कि you change this. Okay. And the other grid operations and efficiency indicator rules. That means even the consumer can also generate their electricity and they may sell to the grid को वापस से, and the meter has a features that meter will move in one direction while selling, and while purchasing it will move in reverse direction. That's the idea. So this is customer side meter to utility operation in home devices and appliances. Advanced or smart meters only achieves part of this vision. Smart metering is a small part of the smart grid. Smart grid itself is infinite. Its depth and breadth is so large that it can know. So smart metering is just a part, a small part. Most utilities focus primarily on advanced metering systems and rarely propose smart grid plans or investment decisions. The smart meter proposals often claim to represent crucial part of future smart grid plan. Unknown ratepayers cost for investment and obtain modernization of transmission and distribution grid. So that is one of the important thing, that is the smart grid, smart metering, that plays important role in transmission and distribution, because the smart grid gives you the information about your distribution and your requirement, and it is just like online system. The information can be sent to the tower and then it will be collected to a point. So like this, this is one of the plan. If a smart meter is being installed in houses, so this will be one of the state of implementing the smart grid, one of the steps, because so many steps are there, because a smart grid is from consumers to the generator, and generators are large number. That means even consumers are also generators, so it becomes infinite number, you can say. So it is bi-directional. So smart metering is one of the steps of the smart grid implementation. Now history of metering. In 1851 earlier the first gas meter was, then electrical meter 1872, then spinning disk power meter, then solid state digital meter, then AMR, then smart meters, that is a two-way communication, and we have the evolution like mechanical, electromechanical, then electronic. So now motivation for a smart grid, that is energy efficiency, CO2 reduction, pricing transparency, and consumer protection. So from manual data to reading. So this is directly going to upload the data, and energy supplier improvement of the billing processes and new policies for customer service and sale product. So two bi-directional. So now it is seen in the picture, that is in the bi-directional information is coming. That's the most advantageous thing, that you don't have to send the paper, that the paper will, when it will come or when it will go and what decision will. So this is not happening. It's just like the mobile, the SMS is coming and going, SMS is coming and going. What is happening in your account, that is also maintained here. So what is a smart meter? So a smart meter measures the energy consumption. So digital measurement, very precise, and it has the memory for storage over a period of time and not just the latest overall consumption values. And transmission transmits the and measurements over a network to remote entities. So these three features are included. You may note down. That is the digital measurement, memory, that is the storage of information and data along with time over a period of time consumption, and the transmission. That means it has the capability to transmit the information to the tower, to the antenna, or it can have the facility to receive also. That means it can transmit as well as receive. So that is bidirectional. Consumer can see and therefore adjust his own power consumption. They can adjust the power consumption and demand also, and power provider can adjust the rates and service charges, expensive rates in peak hours. So even the service provider or the power provider can also change their prices, and consumer can see the prices. Even the consumer can set their demand, and that हमें इतना नहीं चाहिए, हमें इतना चाहिए. So like this. So this is the feature of the smart. Now there are certain features like two-way communication. So smart meters have the capability or ability to send and receive data from the utility. The data is usually sent from the cellular network, Wi-Fi, power lines, and radio frequency. Time of outage, time of usage. The smart meters enables the utility to analyze peak consumption time and bill their consumers premium rate for the peak time usage, and also vary the pricing based on demand. Now outage detection, that is the system is also capable to detect the power outage and fluctuations, thus making it easier to service and repair the faulty lines. That means it gives the information about the faulty situation, and it detects also and inform also that something is wrong. And key features, some of the other features of a smart meters are temper detection, accurate meter reading, power quality monitoring, remote switch on off, and selling electricity back to the grid. That means it can be controlled remotely. From that means you can control from your mobile. Remotely your meter can be adjusted for sending and receiving the information or making the changes in the certain information and data. And somebody if tempering, so today in manual or analog there is a tempering phenomena is very common. So that is also avoided. So various types of meters are here, the electric power, water and gas meters. So many meters are available here, and then analog meter, and then a smart meter, and then single family dwelling and multi-family dwelling. That means in a flat type, so many families are there, so that is also available, and commercial smart meter and residential smart meters. So these are the pictures. So in past we have the analog type of electricity meters that is still seen in our houses. So this is a manual kind of the meters. So smart residential gas meters. So some of the manufacturers are like Elster, Crompton, Etron, Flornidan, and others. Then Dials gas meter, then Landis and Gray, then ultrasonic thermal meter. So these are some features. These are not our interest, but it is there. Now smart metering overview. So where it is water meter or the gas meter or the electricity master. So this is the one of the this phenomena can be utilized in other kind of features also. In water में भी हम लगा सकते हैं इसको, और gas में भी. Today we know that in our Chandigarh the gas can LPG gas is also going in progress. So that can be also regulated in the similar way based on our demand. And separate display. So display is also separately shown in the diagram. And then the data presentation option for customer, that means PC communication. It can be included laptop, PC, and it can be transmitted to remote places for the data acquisition and management, that is control center. That means this is the house the pictures are made within the house. So inside the house we have the such kind of sensor, and from house it goes to the control center. Okay, so the house information has gone to the control center, and from the control center it will come to the house. Now the smart meter technology. So the first technology, that is, we have the analog, that is 1872 to 2005. This analog metering has been used. Even still it has been used most of the places. Then first generation, then second generation, then third generation. The first generation is your automated monthly reads. That is one-way outage detection and temper detection and load profiling. So this AMR, that is automated meter reading. So meter is going to read for 1 month, and it is going to give you the data. And one is AMR plus. That means its feature is slightly advanced. So daily or on demand reads, hourly interval data, outage notification, other commodity reads. So AMR plus is superior than AMR. Now AMI, that is integrated service, that is it is fully advanced metering infrastructure. So this is slightly or it is more advanced than the previous one, because this uses the HAN is home area network. हाँ जी हेलो मैडम. हाँ जी मैडम बोलो, गुड मॉर्निंग. हाँ बोलिए मैडम. हाँ मैं एंट्री करके चेयर में रखा हूँ, अभी आके दे देता हूँ. मैं एंट्री कर दिया.
Could you please elaborate the point that AMR and AMR?
I'm telling you.
For just 1 hour or 1 month. So what does that mean? Once they are given a reading, then only after a month only we can take the reading.
That means for 1 month you can take the reading and it will give the information about the month.
The storage time.
Storage is less. Storage is less there, and it cannot transmit the things. ये ट्रांसमिशन यहाँ पे नहीं है. लोड प्रोफाइल बना टेम्परिंग कोई करता है वो बता देगा. ठीक है. एंड आवरली डेटा नेक्स्ट में AMR प्लस में आवरली डेटा इट कैन बी. So its memory is limited. It cannot provide you much feature. However, the advanced metering, that is, it can give the power quality also. That is the feature of the power that is coming. What are the like harmonics and frequency level, voltage level, that can be seen in that meter. And moreover, the home, it can be interfaced with home area network. Home area network means the information about the home can be sent through this HAN. That means so home information is sent to the central control. So that is called home area network. So so various houses are in a locality and they are all sending and receiving the information. So each house has got its own home area network. Okay? So they are connected. Each house is connected through home area network. So the home area, that means house information is over that network. And remote meter programming, time-based integrated service switches also. So these are the features. This is 2009 and onward. This is implemented in many countries. India is also progressing in this way. Customer role. A customer has flexibility and can choose to be one or more of the following roles: the manufacturer of energy, distributor of energy, provider of meters, provider of metering services, consumer of energy, seller of energy. So because today's the standards, I told you the standards. So standard is one of the important thing. That means there are many products in the market. So one of the meeting in Chandigarh, I was there. So it was felt that the standard is very, because these are all digital. So a device today's what is for our utilization or distribution person, they are not compatible with the smart grid. Those meters cannot run with the smart grid. So compatibility is one of the, so meters, these smart meters are so advanced that that can give you the options for selecting the manufacturer, distributor, meter provider. That means किनसे आपने मीटर लिया, आप उन्हीं से लेना है ना किसी और से लेना है, like this. जैसे you can change the service provider in your mobile.
Between Airtel and Vodafone.
Yeah. So that feature is also there in the smart meter.
So sir, the distribution discom should also they'll have to incorporate this fact, because these days at most of the places in India we have just one distributing company.
Yeah. Abhi in our country, in a smart grid, it has just started at few places. In Gujarat, in Maharashtra, in Delhi, even Tata Power has. So Tata Power is also organizing a international level conference in March, this 2016. So they have invited many manufacturers of the world, as well as the researchers and the faculties, to interact, to just to mobilize the people that you adopt the things. Suppose when LPG gas has come to first time in India, then many people say no, I will not take this LPG. ये खराब है, ये होगा, वो होगा. But today, now the people are quite comfortable with this. So similarly, a smart grid, they say that smart grid आने से हमारा ये खराब हो जाएगा, वो खराब हो जाएगा, पैसा नहीं है. So many things are going to ये, या हमारा जो है बिल ज्यादा बढ़ जाएगा. तो people are afraid of more billing. Consumers have serious questions about smart metering, rate impacts, technology obsolescence, then retire existing working meters. अब वो कहेंगे कि भाई हमारा मीटर खराब हो गया, उसका क्या होगा, हम दूसरा खरीदेंगे. देखिए ये these are the questions of consumers. हम क्यों लेंगे, रेट बढ़ जाएगा, like this. Benefits: operational cost saving, elimination of jobs, meter reading, field operation, demand response, implementation of dynamic pricing, then energy conservation and consumption reduction, part of implementation of a smart grid for T&D operation, integrate renewables and enable electric vehicles also. That means your own energy generated can be also taken into account in this meter. How much energy has been generated by the user. The rooftop can be used for solar power generation. So how much energy is generated, how much you have used, how much you have sold to the grid. So these all features are included here. So utilities often see separate trackers to assure cost recovery outside of a base rate case. Then consumers bear full responsibility for actual costs as per. Now potential for higher bills for low use and low income customers. Then new technology who bears risk of wrong choice, that is also. Then smart metering proposals may be only a down payment on unknown future smart grid. That means down payment today, the whole thing cannot be purchased by consumer, because very handsome amount will be asked. So just like to buy this, the idea is to give the down payment this much and take it. Or a service provider or a manufacturer can be given by you pay in monthly or like this. Benefits are estimated over a 15 to 20 years period. Degree of accuracy never calculated. To documented cost effectiveness, utilities sometimes seek demand response, peak demand response, and supply side benefit that make up over 50% of cost and that require estimates of future prices and capacity of the demand response. Benefits have yet to be proven in any full scale implementation and dynamic pricing. Then Low use and low income elderly customers see benefits or only costs. Obvious the risk that these estimates are wrong. So these are the things related to the smart metering. Consumer concern about consumer protection. So how the consumers are protected. Utilities typically couple smart metering with the functionality of remote connection and disconnection of the meter. Then disconnection for non-payment should be accompanied by a premise visit and attempt to contact the customer to avoid disconnection. Just like mobile में हमारा network चला जाता है. So similarly we have the features in this also. These new meters may give rise to a host of the degraded service options, prepayment, pay in advance, and automatically disconnect when meter is not fed, service limiters, new privacy concern will become evident that with the access to individual household usage information, is anybody home, what appliances are being used, who can access this data and for what purposes. That means your house information is also, that means suppose you go on leave for certain period, so that can be also got from there. Which devices, suppose when you go on leave, so normally your air refrigerator is on, however rest of the things are off. Your CCTV camera may be on, so that can be given the input there and information can be availed that this is. So this is related to basically privacy. This is related to your privacy. So that's why the people may say that no, मेरे को smart meter नहीं लगाना है भाई, हमारे घर की privacy leak हो जाएगी. That is also one of the problem. However, there are many options to now promoters of a smarter grid emphasize how customers can be empowered. Dynamic pricing does not empower customers. It presents the options choice to many low use and low income and elderly customers who must use electricity during peak hours. Customers prefer peak time rebate option in which customers are rewarded for peak load reduction. So now depending upon the peak load and less load time, so the choices is also there. There is a customer, यहाँ तो today we don't have any choice. When it comes, you have to use. When not comes, so that choice is also there. So this is the communication. So yeah, so in house we have the meter, and this we have the HAN, that is house area network. So information that is GPRS, through GPRS that idea is there. Then data concentrator, that is at a transformer. So nearby transformer may have such a kind of things that can from the transformer this meter is connected, and then information is going to send to the control center and then back to the transformer, because accordingly the regulation of power and power quality can be made. And it will also go from control center to the internet, so that if you go from the city outside, even then you can get the information just like your mobile. So this feature is shown here, that web service for customers. Okay, this from house to the internet and house to the control center, both features are shown here. This is the smart meter. Now smart meter communication, multi-utility controller. So we have the multi-utility, that means you have the gas, we have the water and electricity. So for many purposes it can be also used to control. So even the water, today we are talking about the tertiary water, primary water, secondary water. So this kind of features can be also utilized for the water also. A smart meter communication with multi-utility controller. So this is separate unit dedicated for meter data communication, connectivity for electricity, gas, water, and heater. and M bus, that is multi-bus cable and wireless, WAN communication, wide area network, option GPRS or power line और IP
M bus है?
मल्टीपल बस
Okay.
है ना,
Line.
मल्टी यूटिलिटी बस है ना, एम बस जो है मतलब कि मेनी पर्पस के लिए अलग अलग चला जाएगा. यूज ऑफ प्रोटोकॉल सिलेक्टेड फॉर फ्यूचर यूरोपियन स्टैंडर्ड. सो हियर standardization is one of the important thing. So this is one of the figure. This is shown here, that is a smart meter. So just like in a small watches, just like we set the time, we set the date, we set the temperature, etc., etc. So we have the various buttons, and we can have the option to to select the option and see the whatever you require or you can feed. So this is the block diagram of a smart meter. So here is NAN, HAN is a house area network communication module. Then application is, that is your microcontroller based, and NAN is your neighbor area network. यानी कि वहां से आपका नेबर में चला गया, पड़ोस में चला गया, जहां भी वहां पे कम्युनिकेशन का नेटवर्क होगा. एंड देन inside the meter we have the power supply unit, infrared port, then metrology, that is the weather situation is also getting, LCD display is the all, and disconnect switch, connect or disconnect. That is power is whether it is supplied, suppose billing नहीं हुआ तो उनको power काट देंगे, तो that is switching is also, because normally power enters through the meter के थ्रू ही जाता है, मीटर को डिस्कनेक्ट कर दिया automatically. So that feature is also there.
Manual disconnection.
हाँ नहीं, मैनुअल तो होगा ही, मैनुअल तो एक ऑप्शन होगा ही होगा, है ना. एंड दिस इज द कम्युनिकेशन बोर्ड. सो दिस इज टू पार्ट, that is metrology board and the communication board. One is recording and another one is communicating and receiving. Transmitter option. So this is starting from the HAN, that is the house area network. So this is connected to various houses only, and then house area with NAN, that is neighbor area network, and then to WAN, that is wide area network. इस तरह से ये तीनों से कनेक्ट हो गया तो ये इंटरनेट पे भी अवेलेबल हो गया और कंट्रोल सेंटर को भी अवेलेबल हो गया. दिस इज द सिचुएशन, दैट इज 1 2 3. हाँ, इट इज स्टार्टिंग फ्रॉम हैन हाउस एरिया, हाउस से निकल के पड़ोस में गया, पड़ोस से निकल करके और बहुत दूर चला गया, वाइड एरिया नेटवर्क, बड़े नेटवर्क में चला गया. जब बड़े नेटवर्क में चला गया तो एनीबॉडी कैन एनीवेयर कैन बी एक्सेस. Smart meter exceeds building biology exposure limit, transmits in 2.4 gigahertz and 900 megahertz bands simultaneously. This is highly technical, that is the the frequency ranges given here. So just we should concentrate on California Council. It's a smart meter option out, difficult, costly. So this is one of the views, that is about the meter, that is it is difficult, costly, and neighbors. Then relocate meter, costly, neighbors, distance, shielding can be effective, hardwired, HAN, NAN. So this long-term solution, every home has copper pairs and fiber optics is best. So fiber optics is costly. Today's copper can be used for connecting this. Then shielding material, then proliferation of RF, radio conductive power, privacy concern. So these are the issues. So privacy is one of people आर अफ्रेड ऑफ दैट हमारे घर की प्राइवेसी जो है वो लीक हो जाएगी कि घर में कोई है कि नहीं है. द थिंग्स लोड नहीं चल रहा है तो पता चल जाएगा भाई कोई नहीं है. So this is the data collected from the various sources. So smart meters worldwide by 2020 1 billion. Abhi even the USA and UK, they have not fully a smart grid implementation. In certain areas, certain cities they have, but not at all places. So in India has also is taken the initiative in this direction. So about 65 million smart meters in US by 2020 they are planning. 50% penetration of all US household, push for ubiquity, 100% penetration, equivalent to 22% increase in cellular links, and then multiple transmitters per smart meter, multiple transmitters per home area network, and transmitters for neighborhood area network. So dirty power switched mode power supply SMPS. So provide AC to DC to power conversion for smart meters. Electronics distortion of power mains caused by switching regulation. Inrush current at the input results in transients in the form. At home AC wiring services as an antenna to propagate these irregularities as electrical. So what is happening? We everybody know that the more and more the electronic component and devices are using, the more and more the power will become dirty. So that's the dirty power. So dirty power concept, because all distortion. So that's the dirty power. That's why its name is given dirty power. So all the time we are converting this AC to DC, and most of the devices more and more switching phenomena are taking. So again, switching also includes certain transients, and so that way the main power is also going to be disturbed. So we need certain kind of filters, again increasing the cost. So that's also the technically that is called dirty power. This is the issue, and this is one of the things has been shown in the graph. Now power line communication, broadband over power line. So this is one of the anything external source that disturbs the pure sinusoidal waveform of the power means is undesirable. With SMPS, these signals include electric and magnetic fields. So these are also part of the dirty power. Then privacy concern, a smart meter is a stethoscope into our होम. डॉक्टर जिस तरह से उस तरह से आपके घर में एक स्टेथोस्कोप लग गया है जो वहां से दूर से कोई भी चीज पता करके आपके घर में क्या हो रहा है. सो intimate and detailed information about appliances, use recency, profile behavior pattern, commoditization of usage data, allows industry not to sell information on its customers. Utility company control of appliances, peak load management, non-instructive appliance load monitoring, energy consumption prediction using voltage and current changes. Then example, application that threatens our privacy, industry very resistant to opt out. So these are the privacy concern. So that is the people concern, that how they feel. So its solution should be also mitigated. This is the privacy concern. रेफ्रिजरेटर कब चल रहा था, स्टोव कब चला, टोस्टर कब चला, वॉशिंग मशीन कब चला, ये सारा कुछ आपका रिकॉर्ड हो गया. So it can, people do not want to that who is doing at what time. It also says the time. आप कब सोते हो, कब जागते हो, ये सारा चीज आपके बारे में पता चल गया. देखिए one of the graph is shown here. कब आप वो मशीन चलाते हो, कब ब्रेड नाश्ता करते हो. So these things are shown here, that our privacy is leak out there due to the smart meter. That means when you are using the refrigerator, when you are taking the breakfast, when you are using the washing machine, like this. So privacy is one of the important thing. Over 24 hours when you are going to sleep. So these things are also included in your smart meter. So proliferation of RF will continue to ramp. RF is migrating closer into our personal space. Hence are likely to exceed even the FSC and MP levels, and especially when combined with other home wireless technology. Smart meters are programmable devices with an industry seeking to develop new appliances that are likely to go viral. So these are certain points. Then our private information will be customized and sold. That is one. Today, you know that your mobile you will get many unknown calls. From where this is coming? Because our mobile number is sold. So like this, your house data, your personal data will be sold. That is one of the biggest, that is your smart meter. So we are turning our homes and commodities in large microwave ovens. We are participants in the largest biological experiments on the planet without our consent. So this is the point. Thank you all.
Hello. I think you had a good exposure on smart metering. Now you can ask questions. Any one of you from any center? Modi University? You have any questions?
Good morning, madam.
Good morning.
Hello.
Yes.
Myself. Hello, madam.
Yes,
Good morning.
you,
Myself, Dr. Farooq Hussain, MIT Muradabad. I would like to ask one question.
yes.
What are the obstacles to use smart meters in India?
Yeah. The first thing
And
is
up to
that.
which date this can be implemented?
No, yeah, I'm answering you. First thing is that the smart meter is being used. It's a part of the smart grid. Just I have told you in my lecture that is one of the component in a smart grid. Okay, so this is to be incorporated with the smart grid. In our India, the smart grid implementation has just started at few places, like Tata Power is doing something, and in March there is a conference, international level conference being organized by the Tata Power from 15 to 18 or so in March 2016 in Gujarat and Maharashtra somewhere, this smart grid implementation. So smart metering is one of the part of the smart grid. So before going to the smart meter, one should understand the smart grid. Just I have given you the brief in the beginning. So
thank you, sir. I have one more question, sir.
Yes,
and
sir.
how different prepaid meter from smart meter now?
No.
What are the difference between prepaid meter and smart meter now?
Yeah, prepaid meter is just like your prepaid mobile services. Okay, so this meter has got the feature of more than the prepaid meter. This is smart metering and the prepaid. So this has also the prepaid facility. The smart meter has got also the prepaid facility. However, a simple prepaid meter cannot be so much smart, but still is smart. So the more and more features are being incorporated in the smart meter. You have seen that how it is being linked with the house area network to the NAN or to the WAN. So what is WAN? That is wide area network, and you have the facility to that is plug and play kind of features in this smart grid with your meter. Okay.
Thank you, sir.
Okay.
Anybody else?
Hello.
Yes.
Hello.
Hello.
Hello. I am from IEC City Greater Noida.
Yes.
Yes, sir. My question is, what are the system implied into our hacking or correcting in the system?
In our country.
Yeah.
No, in our country still we have the conventional system, like we
How,
have the
my question is
electromechanical.
how you
Hello.
manage to avoid cracking or hacking in the system?
Hacking.
Yeah.
Yeah, that is the security aspect
We
of
had a lecture on cyber security yesterday, how we can
uh, very
all
much.
those.
My concern is privacy concern.
Yeah.
Uh, uh.
That is the privacy concern. So how the security as that's another faculty member may give the details of the security concern about this smart grid and smart metering, because our privacy, just now I told you that our privacy is now quite leaked over 24 hours of time, what you are doing and what is happening in your house, all things are being leak out. So another faculty will say about this. Well, okay. Any more questions, sir?
Hello,
Haji.
uh, I am speaking from Rajasthan Technical University, Kota.
Yes.
I'm Professor Dinesh Birla. Uh, I wish to get a clarification on smart metering, uh,
Yes.
one aspect of protection engineering.
Yeah.
It is okay that we can rely on smart metering for the measurement and monitoring purpose. Uh,
Of course. Of course.
is it so that we can use the this metering and at the same time transfer the metering components for adaptive protection, where the protection can be offered online depending on the latest online changing conditions, relying on this metering values.
Yeah, that means you are talking about the protection of the devices or the protection of the house or protection of the meter. What?
Let us say protection of the main equipment, generator, transformer there in the field,
Of
and
course. Yeah. I am telling you. I am telling you the fact regarding, because it is part of the smart grid. Our transformer is also smart. That is our, in this case, when we are using the smart meter, our transformer is smart enough to control all those things. So the protection is fully protected. It is fully digital. So we don't have to bother about that protection. It's fully protected. That means
yes.
devices, I'm telling more information I'm giving you. That transformer is so intelligent, that is called intelligent transformer, that it can tell you in advance that what is going to happen, and you replace that kind device to take the preventive action in advance. So your device is or transformer is fully protected.
Okay, sir. Fine. Sir, a related question regarding this: can this measured information by the smart meters uh, be transferred online to the relay for protective relaying, and then the relay may change its setting, uh, so that the protection, depending on the latest online changing conditions, may be modified. Is it so possible?
Yeah, it's a fully intelligent. It can do anything because it's a digital system. It's a computer-based system. It can do anything. It can take a record of all things and make a decision.
Okay, sir. Thank you, sir.
Good morning, sir. Hello. Good morning, sir. Yeah.
सर ये देखो ना एक बार आके
अच्छा, यार वो उनका
सेशन तो हो गया पर
नेट कनेक्शन उनका गया, अपना बस चल रहा है। उनके कुछ प्रॉब्लम हो,
वैलिडिटी कर जाए।
वो एक्चुअली गया, अपने डिस्कशन हुआ।
अच्छा,
इसके बाद में क्या चला ही गया।
2 मिनट।
हाँ, इन्होंने कहीं वो ध्यान नहीं दिया।
उल्टा लग गया ये कैमरा, कैमरा उल्टा दे रहा है। तो मैडम ऐसे कह रही है वहाँ पे लाइट चली गई हमारे, तो इसलिए हम वहाँ पे कनेक्ट नहीं हो पा रहे हैं। और 2 बजे 7 बजे इलेक्ट्रिक ले रहे हैं।
टी ब्रेक हो गया, टी ब्रेक हो गया, उनकी लाइट भी चली गई, इसलिए बंद
Good morning. I hope you are back after the tea break. Hello. Am I audible to all of you? Have all of you come back after the tea break?
Yes, madam. Yes, madam. RT Kota from RT Kota. Everybody is there.
RTU, Mahendra Lalwani?
Yes, madam. Everybody is there.
Everybody is there. Okay.
Thank you, madam.
We are having an expert from a firm, a company, EcoSense Sustainable Solutions, Delhi. He is Rishikesh, R&D engineer. They make laboratory simulators for the renewable energy sources. Like they have solar emulator, wind emulator, and we have purchased from them, and they are means our master's degree students are doing research and all in those areas. If some of you are interested in seeing the practical setup because you had a course on smart grid on online basis, but if you require perfect practical exposure, you can take some time, or we will do some course in the next year in contact mode on this area, renewable energy sources, so that you can come here and we can give you practical exposures on all this, on all these emulators, wind, solar, and we have a fuel cell also. And they can be connected together and hybrid, and then connected to the grid also, because a sort of a micro grid we can set up using those emulators which we have in the department. So we have procured them from them only, EcoSense Solutions. So in this session he will be talking on a hybrid PV, wind and fuel cell. Okay, so I told him to speak on mainly fuel cells also, because you didn't have much exposure on fuel cells, how they work. So he will be giving you a idea on fuel cells, and then working on how you can, what are their different laboratory equipments they will show you, and how they can be connected in hybrid, so that it will work as a microgrid or a connected standalone islanded or grid connected microgrid. Canopies, Raju. A fuel cell PPT.
Right.
So he is Mr. Rishikesh. I told him to speak on about his company also, so that all of you will come to know about them, what they manufacture, and how they help institutions and students in doing all these experiments. Like, you know, yesterday you have seen how a wind turbine is installed, and many a time we will not get opportunity to see all this, or we don't have facilities to install a wind turbine in our college. But then how will you learn? How will you do experiments? So they have small emulator setup of wind, PV, and similarly fuel cell also. So he will talk about all those and how you can hybrid connect all this. So over to Rishikesh. I think by 1 we will have a lunch break, and then we will reassemble again by 2:50 and have a formal valedictory section. And you can give your feedback also during that time, and then we will finish the course by 3 or 3:30. Okay, so this is your last lecture of this course, and you can give me the feedback of all the lectures throughout the week, and you hope you will have a good time during this lecture also. Thank you so much. Over to Rishikesh.
Good morning, everybody. Myself Rishikesh. I work with EcoSense Sustainable Solutions as an R&D engineer. Today's my topic is introductions to fuel cell and some of the hybrid concepts I would like to touch upon, like PV and supercapacitors and battery systems, which are the emerging research area in India as well as in other countries. So before beginning, I would like to say how the structure of this talk goes. Like, I'll give a brief introduction, what's happening in India and what are the current status. And also I'll walk you through types of fuel cells and their production systems. And later I'll talk about the basic performance. At the end of the day, economics matter. So we'll talk about the cost and their implications. And later we'll come to applications where the fuel cells are actually used and what type of fuel cells are used at what kind of applications. And later we'll come to a case study. We have done this case study in Bihar, as well as we have done scaled down the systems in our laboratory to actually develop the research products. Then later we'll talk about the future prospects, what being a research fellows and students and academicians, what all you can do in this area. So this is just, I'll give a snapshot what was the current status. We have the data I have took is till August last year, since I'm considered the installed capacity, not the operational capacity, not the installed capacity. So with, in which renewables only contribute 14%, but coming to the future, will definitely reach to 30 or 40%, similar to Germany, which is currently the renewables take the major part in the generation. So we need to consider how the grid is going to behave under such situations when you keep on pumping the fluctuating sources or unpredictable sources, whether the Indian grid is capable of taking that fluctuations or not. What are the additions has to be implemented to the Indian grid so as not to make the system down or the complete blackout. And there is a policies coming out to huge scale deployment of renewables requiring strategies compared to handling conventional energy sources. You can handle a coal power plant or other conventional plant by actually forecasting, but whereas coming to the renewable energy sources, you need accurate forecasting strategies to deploy large scale development. And since they are variable in nature, handling the variable sources requires additional investment, right? So that investment has to be done on the existing grid, or the new infrastructure has to be coming, that has to be decided. And the problem becomes complicated when we keep on adding the supply side sources as renewables. The same case in the, consider the case of Tamil Nadu, where you have 40% injection of wind energy in the total capacity addition. So they are facing huge blackouts for agriculture because wind is unpredictable and the forecasting techniques are very poor in the country. So this is the operational capacity, 34 gigawatt, which is in operation. You can see the diagram here, where the major chunk is by wind energy, and later followed by the PV and other renewable energy sources. So the future would be of like more of solar, less of wind, taking consideration of the current policy levels. And this is for the conventional energy sources, and it's same like the state. I divided into which different sectors: private, central, and state. State sectors actually take the role in this. And coming to the type of generation, coal followed by the gas, oil, hydro, nuclear, and the last is renewable energy sources, as I've said in my earlier slide. So this is the possible world scenario of energy. You can see here in the graph, in till 2040, the scenario will be majorly dominated by the coal, which is a conventional one, and the later you can see the wind, PV, and the solar thermal as well, biomass, geothermal heat will be coming to the picture. So there has to be a place where we are moving from fuel to electricity generation, from electricity generation to fuel. That there comes the hydrogen generation. I'll show you in my next slide. So you can see here, if you see the in between 2010 to 2030, there is a transition phase where you are generating electricity from the fuel like the coal and other systems which are less efficient, and later the phase would be coming to electricity to fuel. You know, like you will generate electricity at the remote areas, and you will convert into a hydrogen fuel, and later you can transport that hydrogen fuel to the demands and so that they can generate there itself using the fuel cells and all these sources. So this is the secondary energy carrier. What I was saying, you can see here, you will generate wind energy and then you will transmit for longer distances, and there is a load end where they consume the energy. And now the scenario will change. You will generate and you will convert into hydrogen fuel, at the source itself, and then you transport that with some intelligent sources, and later you'll use at the load end by using fuel cells. Since this technology have not commercialized, research is happening to cut down the cost. How can we come at the end of the day? Levelized cost of electricity generation matters. Whatever you are generating, okay, the clean energy obviously you need to consider while doing all the analysis, but you need also to consider the economics of generation. So this is a volumetric density. Okay, I'm going to generate through hydrogen fuel. What is the volumetric density it's going to occupy? Whether I'm going to afford that space, or whether I'm going to afford that transport costs from one location to other. This is you can see the crude oil which has less higher volumetric density, and at the same time higher energy storage capacity, 10,000 units per meter cube. Whereas compared to the hydrogen, you can see 170 units per meter cube. So these are the assumptions made at different pressures. Okay, and as the pressure and temperature changes, the storage capacities do change. And you can see the pumped hydro, which is a minimal 0.7 units per meter cube. So this is the only energy backup, as I say, the pumped hydro plants you can see in India have, compared to the hydrogen and other things. So these are some production paths. Okay, I have generation from different clean energy sources, direct solar, biomass, solar PV, wind, geothermal, and the nuclear, coal, and oil. So after generating from this, can I convert this directly into a hydrogen fluid so that I can use at the load end? There is, you can see the electricity for electrolysis and also radioactive waste in case of nuclear, and the end product will be the hydrogen storage and the utilization. So this is a future energy landscape. So everywhere in every part of the urban areas, you'll be finding these hydrogen cylinders where you can transport and use at the load end. They're also used in the electric vehicles. You already had this session on EVs using fuel cells and batteries. I'll not touch upon that thing today. So these are the production methods depending on the different various methods like thermal, electrochemical, and biological. And there are different processes. Whereas in thermal, you'll go for steam reforming, and the source will be the natural gas. If you go for thermochemical water splitting, the source will be the water, and that will be operated at higher temperature from nuclear reactor. And there are also gasification. It's from the sources of coal and biomass. The other thing would be the electrochemical, which is generally adopted in most of the fuel cells. If you go to the market, you'll find 1 kilowatt to 5 kilowatt fuel cell stacks, which are commercially available in the market. They are operated through this process, electrochemical process, and the source would be the water in some cases, and the output energy would be electricity from solar or hydro or nuclear. You can generate that process via this clean energy routes. And the last is a biological, where you see different biological methods to generate hydrogen fuel. So let us come to a chronology, how actually the scenario started. It started from 1839, where the first electrochemical H2O2 reaction to generate energy. Then the research continued, and it was developed by the General Electric, the solid ion exchange H2 fuel cell used by NASA in spacecrafts, and later it keep on emerging, and it came in 1970s. We have seen this in vehicle manufacturers, electric fuel cell electric vehicles, which come in 1970s, and later the California Air Resources Board introduced a zero emission vehicle, where it's completely run by solar, which is converted into hydrogen, and later it's completely run by fuel cell systems. And later many of the companies came into the market to commercialize these fuel stacks, but currently they are very much costlier compared to other energy sources, but their applications are vivid depending on the areas. I'll discuss a case study in which you'll be seeing supercapacitors, fuel cell, and a battery and a electric vehicle. How do you need to size that, and how do you need to optimize the fuel cell to actually get much out of it? And currently, as I said, you'll be getting fuel cell stacks which are commercialized in small segments. So what is fuel cell? What does it do? A fuel cell is an electrochemical device. It's similar to a battery, whereas in a battery you need to worry about charging and discharging, right? Whereas in fuel cell, as long as you're supplying the fuel, it keeps on generating. So is no need of worrying whether the fuel cell will come down or. So how does it work? In a typical fuel cell, gas, hydrogen, is fed continuously to the anode compartment, and an oxidant, example oxygen, it can be got from the air and is fed continuously to the cathode, that is a positive electrode compartment, and electrochemical reactions take place at the electrodes to produce electric current. So this is the basic reactions what happens inside the fuel cell. That anode, the hydrogen will split into ions producing electrons, and the cathode, the oxygen, will combine with these ions. The byproduct will be the water. So it's clean and neat, and it's less. There is zero noise from this source. So it will be a silent generator which is producing the end product as a water. So overall, the hydrogen combines with oxygen to form H2O. So these are some of the main components which you have electrode, which is a thin catalyst which is pressed between the ionomer and the membrane, the porous. This is a conductive substrate. And we have electrolyte. This is a chemical compound that conducts ion from electrode to other inside a fuel cell. And other than catalyst, which actually this substance causes speeds up the chemical reaction, which you already learned the basics of chemistry in the school level. The other thing is the bipolar plates. So the commercially available fuel cells having this bipolar plates, where at one plate you can actually find the other side as anode, the other side as cathode to adjacent cell. And there is a gas diffusion layer which is connected behind the bipolar plates, which is also called electrode substrate or diffuser. I'll show the main components, how the fuel stack will look like. This is the how does the right side you can see this is a commercially available fuel cell stack where you can see the oxygen inlet and oxygen outlet and hydrogen inlet one end, and sorry. I can't do in the PPT, I guess. Okay, fine. So the blue one you can see, I'll read out the blue ones. What you will see in the right end is a membrane electrode assembly, and in between there is a bipolar plate. That's what I was explaining, wherein the gas actually flows, and the blue one is a membrane electrode assembly where you'll find the positive and negative electrodes and anodes. So from where you will actually collect the electricity. So the current fuel cells which are available in the market are efficient up to 65% to 65%. Depends on the type of fuel and depend the types of membrane you are using. I'll also talk about the different types of membranes. So this is a general comparison of fuel cell with internal combustion engines. Okay, you have chemical energy of fuels, and later you'll convert to thermal, and later to mechanical, and later to electrical. That is one path which we currently follow in power plants, in conventional power plants, where coal is fired and it's converted to thermal, and later to rotating devices, mechanical energy, and later to other form electric energy. So the complete combustion process has a Carnot cycle has an efficiency of 40 to 45%. You are already aware of that. Whereas in fuel cell, it's a direct process. Chemical energy of fuels is converted into direct electrical energy by just collecting the electrode and anode and cathodes. So this is a conversion efficiency of fuel cells. As the temperature keeps on increasing in fuel cell, the efficiency dips down. You can see in the graph. Whereas in the Carnot efficiency, you'll find the reverse phenomenon. As the temperature increases, the efficiency increases. So coming to the different types of fuel cells, depending on they're differentiated by type of fuel used in that, and also the operating pressure and temperature, and depending on the area of application, at what voltage or at what current levels you actually require the output from the fuel cell. And they're also distinguished by type of electrolyte material used as a medium for the internal transfer of ions, and also the type of electrolyte determines the operating temperature. So I'll also show you the various types of fuel cells with different operating temperatures and their applications. The choice again depends on what kind of applications you are looking for. Currently in electric vehicles or most of the applications we use proton exchange membrane. Since the reason behind that I can show you in this slide. So alkaline based fuel cell electrical efficiency is of 35 to 55, and the power ranges also varies, like you will get in 10 kilowatt to 100 kilowatt. And that is a direct methanol fuel cell where you will get in the range of 100 kilowatt to 1 megawatt. So these are very costly as well, and they have the less efficiency, but the cost of generation is minimal compared to other things. And we have phosphoric acid fuel cell, which are developed at 10 megawatt. They are in the research phase. As such, there is no bigger plants using fuel cells. The reason behind them is they actually take much time to meet the load demand, similar to the coal-powered or nuclear power plants. So we have molten carbonate fuel cell will come in the range of 100 megawatt, and followed by the solid oxide, which is more than 100 megawatt, and the other is the proton exchange membrane, 100 watt to 500 kilowatt. This is what I was talking about, which you can get the stacks of 100 watt, and nowadays they are also developing 50 watt, so at a max of 500 kilowatt, and the working temperature is very minimal, 50 to 100 degrees Celsius, so you no need to adapt a cooling strategies or methods to bring the increased efficiency, and they have the good efficiency in the range of 35 to 45, and they are commercially used in the market now.
Excuse me, these are named after the fuel that we are putting to the fuel cell, or the electrolyte, or alkaline direct methanol. So this direct methanol is the fuel that we.
Yeah, it's fuel. It's a procedure to develop hydrogen at the end of the day.
Okay. And basically we'll be putting.
We'll put a hydrogen, but how you produce that hydrogen, that depends on this. And these are some of the characteristics. Okay, I have these different kinds of fuel cells, and they have some merits and demerits. So depending on that, you need to intersect the application. Coming to phosphoric acid fuel cell, it's low temperature, suitable for portable device applications. It can be transferred from one place to another. And undesirable attributes comes to the use expensive platinum as a catalyst, and is a poor conductor at low temperatures. The PEM is a low operating temperature, suitable for transportation. This is as well, but it has high power density, which we actually installed in NITTTR. There is a PEM kind of fuel cell. We are trying to integrate with wind and as well as PV, so to form a DC microgrid. And this uses expensive platinum as catalyst and is sensitive to fuel impurities. The other molten carbonate fuel cell has a high operating temperature, improves efficiency for baseload plants. This generally used in peak shaving of power plants. This is used in some parts of US, not suitable for small sized applications. Coming to solid oxide fuel cell, which have high operating temperatures, and these are also used for baseload power plants. And coming to the research kind of level, they are not actually deployed in some countries since they are very much costlier. And the other thing is the alkaline fuel cells, which are low temperature and high fuel to electricity efficiency. You need to pump 60% higher fuel to get the same amount of electricity in this. And the requirement of pure hydrogen, and this is very allergic to carbon dioxide. So the other method is the direct method, wherein you eliminate the need of fuel reformer drawing. The case study which I'm going to show you today will be using the two-way kind of fuel cell. I mean, when there is a power, it will generate hydrogen, and when there is a deficient in power, it will generate electricity. So this is a basic difference between fuel cell versus a battery. Whereas in battery, as I said, it's convert chemical to electrical, but we need to charge depending on the state of charge of the battery. Whereas in fuel cell, it keeps on generating. The right picture you can see, this is the stack what we have installed here. You can see the different electrodes that coming out from the fuel cell. The membrane, the person who you can see in his hands, you can see the membrane, the electrode membrane. this is a comparison of fuel cell system and internal combustion. Like, okay, if I'm going to design an electric vehicle, or if I'm going to design a application based on fuel cell, how the efficiency going to look like? We have compared this with diesel and other applications. The fuel cell, you can see the have the high efficiency compared to the other applications what we currently using. So this is a case study which I'm going to show today, which includes fuel cell, battery, supercapacitor, hybrid system. The reason why we are going for this kind of stuff is we have limited fossil fuel reserves, increasing interest in hydrogen as a clean and sustainable alternative, and fuel cell hybrid system vehicles yet to enter large scale commercialization phase. The blueprint which we have got from the Indian government for developing smart cities in India has the fuel cell based electric vehicles as an initiative in their blueprint. So we need to consider this is one of the good potential area one has to work on to commercialize this segment. They are characterized, and these things are characterized by fuel cell as a main system, which is a source, and a battery as a backup, and a supercapacitor as an energy storage system, because to overcome the immediate transients, we need to have an immediate source which can take care of the transients. So fuel cell exhibits slow dynamics, as I said, and long startup times. So if there is sudden change in load, fuel cell has to accommodate that sudden changes. So to overcome this drawback of fuel cell, we are using supercapacitor, and also we need to use a dump load. If there is a sudden dip in demand, the fuel cell also has to come down, but that doesn't happen. So we need to have super capacitors which will charge and discharge accordingly to overcome these issues. And at the end of the day, we need to design a durable system which has to minimum it has to run for 5,000 hours. So so we need to model a system depending after sizing the system. Modeling and power management design and optimization of fuel cell, battery, supercapacitor, hybrid system. So we'll size the system and then we'll optimize its working. Supercapacitor, as I said, is responsible for peak power demands, and the battery assists the supercapacitor in fulfilling the transient power demanded by controlling its state of energy. So we'll consider a case study where there is a huge fluctuation of the train, and how does the fuel cell is going to respond for that using supercapacitor and battery. So this is the block diagram that was talking about. You have SC, the supercapacitor, and you have bidirectional converter placed ahead of it, and you also have FCS, fuel cell stack, and we have a battery system which is the last block you can see. And you can also place a converter in front of battery to actually control the state of charge and discharge, but to avoid the more optimization techniques comes into the picture. Since the control variables keeps on changing, you need to have a multi-objective function to control all these three sources as the three sources you can say. And later you have an inverter at a DC bus, the point of common coupling, you can see the three arrows coming to one side, and that is a DC grid. And later you have inverter which converts into AC, and then we have a motor, that's an induction motor that can also be controllable. You can also place a control algorithm behind that. Again, the multi-objective function has to be decided. Later you have a train, and that is connected to the wheel or shaft of the application you are using.
Please explain why I have to use a converter after the battery bank?
Here in this case we have considered this is small scale system, 1 kilowatt system. We have scaled down it. You can also use a converter to control the charge of the battery. Like if you want to deep discharge, you can use a controller there. If you want to
consider the battery voltage as the DC
limit. Right, DC limit. This is a block diagram, and this is a vehicle model case study that was I'm talking about. So sizing depends. You actually need to calculate the force required by the tram to overcome the friction. There are four forces which actually dominate the movement of the vehicle. That is acceleration force. It depends on how speed you want to go, and the second thing is the force required to overcome the aerodynamic drag, the drag which is forced by the air, and the third thing is the force required to overcome the rolling friction. This is a friction between the tires and the road or the track you're using. And the last thing is a gravity force. If there is a declined area, if there is a declination or inclination, then you need to consider the gravity force as well. So combining all these forces will calculate the force required to overcome all these opposite forces, and will define the size of the fuel cell, battery, and supercapacitors according to the overall force required.
Shouldn't this be V cube in the air drag component part?
Which one?
Half rho CA V cube.
Uh,
It's the air drag component, right?
Right.
I mean, it should be cubic.
No, you have considered the CD here, right? If you take that, the V cube comes. Like you're considering the wind kind of thing, right? No, that comes in wind, but you're considering the CD coefficient here. If you remove that coefficient, you'll get the V cube what you get in wind energy system. So we are considering this as a speed profile. Okay, there is a huge surge, as you can see. The time is in seconds. I'm considering 1,000 seconds profile, and in the y-axis you can see the speed required, and also the kind of changes you are looking, the speed versus time. So with this kind of profile, can I design a system which can meet this kind of demand using fuel cell, supercapacitor, and battery? So the objective function would be, if I'm increasing the acceleration, I need a more power. If I'm decreasing if I'm decelerating, the power has to be given back to the battery. In this case, we are not considering back to the battery, but we are considering these surges are within seconds. We need a device which can charge, within seconds. The only reliable source we can see is a supercapacitor. So before modeling of this fuel cell stack and its DC-DC converter, this is the efficiency and the consumption rate of a fuel cell. You can see here the hydrogen consumption rate versus the DC-DC converter output. As the power increases, the consumption increases. You can see it's a almost linear kind of graph, the left one, and in the right you can see the green color one is the DC efficiency you are getting at the DC bus, and also fuel cell stack efficiency, the blue one. As the power output increases, we have considered a 1 kilowatt fuel cell here. We scaled down the model to this in the test bed. So you can see after 100 watt, the fuel cell efficiency almost remains same. So you have flexibility to operate within the range of 100 to 700 watt. So again, we need to model a battery as well, right? Modeling a battery depends on this internal resistance. At the time of charging, you'll see the different resistance, and at the time of discharging, you'll see a different resistance. So these are the characteristics you can see at the right end. The blue one shows you the open circuit voltage depending on state of charge. Completely charged, you'll get a higher voltage, and the zero, you'll get a minimum voltage, and the red lines defines the change in resistance with change in the state of charge. So you need to consider this as well while designing the system. So coming to the supercapacitor, you need to also consider the supercapacitor characteristics. You are using bidirectional converter ahead of supercapacitor to flow the power in and out. The efficiency of the supercapacitor in the both modes remains almost same, and you can see the left side graph. The power, the PSC shows the left y-axis shows the power at the supercapacitor, and the PSC DC, the x-axis, shows the power which is available at the DC bus. So you need to take care of this thing. If the power available at the DC bus is 500 watts, the supercapacitor has to be in a state to discharge 500 watts instantaneously. So what is the strategy we are going to deploy behind this? We have the triple hybrid since it's a multiple input, multiple output system, MIMO, we need to control the power of fuel cell, we need to control the power of DC bus, and we need to manipulate the variables and we need to control the variables, supercapacitor variable as an output control variables. And the logic is like supercapacitor is supposed to take the care of transients. That is a logic behind this. And who is going to supply that sudden power to the supercapacitor? That will be done by the battery. It charges fast, so it requires a fast power source. So fast power source being the battery, it will give the instantaneous power to the supercapacitor to charge. And battery is responsible for smaller fractions of the transient demand state, changes slow. So the battery can't come into the picture suddenly within the microsecond level to cut down the surges. So the battery require a slow system like fuel cell. So fuel cell will charge the battery. The battery will give the instantaneous power to the supercapacitor.
And which battery source is providing the continuous power?
Lithium ion.
So the battery will be providing
the battery will providing the continuous power to the supercapacitor. Since it charges very fastly, so it can actually discharge also very fastly to the load demand. So the transience is covered by the capacitor, and supercapacitor. Since fuel cell can't give a sudden demand to the supercapacitor, it will charge the battery. So
basically, it is the fuel cell charging the battery
and the battery
charging the
supercapacitor. In the case of transients, fuel cell will be continuously serving the base load, but in case of transients, the battery will charge and the battery will give power to the supercapacitor to avoid the to overcome this transients. So this is a logic we need to follow, and we use the proportional integral controller here to regulate the state of battery state and DC bus state. So this is the at the end of the day, you need to control the hydrogen fuel rate of fuel depending on the variables. As I said, the variables will be you can see the block diagram underneath here. We are using PI controller. There is again a saturation limiter because you can't pump hydrogen fuel as much as you can. So we need to have a rate limiter, which we are considered 10 watt per second. That is the power of hydrogen you're going to feed that, and there is a DC bus output where you are actually regulating that. So these are the outputs you can see. There is a power demand. That is after getting the cycle, the acceleration cycle. I have shown you the surges and the base load. Depending on that, we calculate the power demand. The blue one, the first graph you can see, it shows the power demand you required. So you need to meet this fluctuating and very undesirable demand. So we consider the worst case so that it can meet the best case scenarios. So after that, you can see the second graph. The red one shows the DC supercapacitor DC power, and the blue one and the green one shows the fuel cell. So underneath you can see the supercapacitor graph that is meeting the load demands. So the supercapacitor is actually supplying the transients. So the last graph shows the battery state of charge. So depending on the supercapacitor charging and discharging, the battery graph what we got here, you can see here. So the second graph shows the three power sources which are going to, when you add up the three power sources, it's going to meet the load demand, and the third graph shows the fluctuating output and input of the supercapacitor. So one thing we have faced here is the durability. As I said, the minimum lifetime has to be 5,000 hours to comparable with the current automotive engines. And the only aging effect what we have observed is the load dynamics. So if there is a huge load dynamics, and the fuel cell efficiency and also the lifetime is going to deteriorate. Load changing leads to many degradation effects. Like the degradation effects is like porous media flooding and dehydration of the membrane. So you need to have a continuous cooling chamber to keep the fuel cell efficient, and also the catalyst layer keeps on pumping out due to gas travation, and the load dynamics should be limited in order to increase the fuel cell stack lifetime. This is what we have observed from the overall case study. And so once you the second case study I'm talking about was how to optimize the microgrid with fuel cell and PV. So you are designing a fuel cell and a PV. So can I get maximum out of it? Like the objective here is this case study we considered for a location in Bihar where it's completely isolated place. We need to deploy a plant there using photovoltaic and a battery actually, but we are planning to deploy with a fuel cell because we need to show this as a case study to optimize the cost using fuel cell and PV in microgrid. So the objective here was to reduce the line losses and to optimally use the fuel cell. In this case, we are using a reversible fuel cell. That means when there is surplus generation of PV, the fuel cell has to generate hydrogen, and when there is deficient, it has to supply to the grid. So in this case, we have considered a 0.5 megawatt and 1 megawatt PV plant, and there are 6 load segments and 2 URFC. That's what I'm talking about. URFC fuel cell, which is of 30 kilowatt with 100 unit storage capability. Okay, we are considering 2 fuel cells here. So the objective would be to minimize the operational cost of microgrid by defining a value function depending on the line loss. So at the end of the optimization, the line loss has to be minimized. So and also the fuel input has to be optimized. So the storage energy will be reduced. So why we are not deployed for batteries is we want to showcase by using fuel cells, we want to reduce the cost of storage. So the network and the time domain complexity related with function are resolved by implementation of heuristic optimization techniques. So the algorithms, I'll show what all the algorithms we have used to optimize the line losses in combination. Since we have already we are aware of what kind of load we are going to see. Since the load we have forecasted, depending, since it's isolated one, we have the forecasted load for that location. So depending on that, we actually designed this system. We have a load forecast for 24 hours available along with the generation from PV, because PV is 80% predictable. You have different forecasting techniques that can, once you have the data for that location, you can forecast using P50, P90 models, which are available, which are sold out, which are sold by MNRE as well. And there are also some agencies, they like Solar GIS, they sell this data with P50 and P90 accuracy. Depending on the accuracy, you can predict the solar photovoltaic output. Both, and then we have the constraints we need to consider while defining this network.
Excuse me. During the discharging process, the fuel cell will be consuming the hydrogen.
During the discharge process, it will consume the electricity. It will consume the electricity, and using electricity, as I shown in my earlier slides, using electricity you can convert metal hydride to hydrogen.
So this is when the fuel cell is charging itself, right?
Right. Fuel cell is charging. It's like a battery.
So this charging process takes place with the same electrolyte and membrane that we
right.
or a separate electrolyte?
No, it's in the same electrolyte.
So this same electrolyte, it uses hydrogen to produce electricity as well,
and it will take the electricity and it will generate the hydrogen
whenever it's in excess.
Right.
The same electrolyte.
Same electrolyte. So this is a line diagram we have considered here. You can see the two photovoltaic plants, the upper and lower, and you have 2 URFC, the fuel cells, what I'm talking about, the stack are connected different sources, and there is we also design an artificial grid so as to think in case in future if a grid comes into the picture, how does the system is going to behave. So we can directly integrate the existing system into the grid so that the current system will not fail in the coming future. And also we have capacitor banks, since reactive power has to be injected into the grid as and when required to maintain the voltage profile. So we also have 0.3 MVAr capacitor. You can see which is right side of the utility grid, the artificial utility grid we have considered here. So this is a load generation curves for 24 hours, and there are some network constraints what we have considered here. The total load demand forecast along with generation from PV is 1 megawatt and 0.5 megawatt, as I said. And the graphs which you can see at the left side of the slide, one is the load demand. The first graph is the load demand, and the second graph is a PV generation profile, and third is you need to these are the two renewables, the last two graphs you can see.
What is the x-axis?
X-axis is the power capacity. So at the right end you can see the different symbols that I have showcased here in this bus. One is a power line, but it has in constraints, like there is a current limit for the conductors, right? So it should not go beyond certain limit. And the second thing is the load. Load has a constraints of consuming the active power and also the reactive power, and you need to maintain a voltage profile, right? So many different equipments have different voltage ratings, so you need to take care of those ratings. And the third thing is a PV panel. What are the constraints with the PV panel? It will only generate active power, right? So there is no reactive power, so you need to pump the reactive power as and when required. And it can generate maximum open circuit voltage VOC and a minimum voltage which is very far less than the open circuit voltage. And coming to the what are the constant with the fuel cell system. The fuel cell system is as I said, a very slow device, but since we are using a reversible process, this will not be a problem in this. So it has it operates in two modes. One is charging mode and other is discharging mode. In the charging mode, it also has constraint like the maximum power it can consume, and also the discharging mode, the same case, the constant is the maximum discharge it can do. And what are the constraints with the grid if you're going to integrate in future? So the grid, you might be aware of the grid scenario. You need to take care of the total harmonic distortion. You need to take care of the reactive power consideration. You need to take care of the frequency. All this the basic things has to be come into the picture to synchronize with the grid, the existing system. So once you have this all things in your mind, then you need to formulate the problem. What is the problem we are going to face? Okay, the loads are distributed. You can see from this graph. I'm switching to the previous slides. You can see the L1, L2, L3, L5. These are the different load segments which are distributed, and I also considered impedance between the lines. You can see impedance of 0.07 plus 0.2 ohms in between the lines. So you need to consider the problem is you need to reduce the losses. So I'm generating at one source. I have distributed the loads as well as the renewable end sources so as to generate and consume at one point. But what if there is a no generation at one PV plant? So can I transport that power from one source to the other by avoiding the losses? So the objective is to reduce the losses in this case. At the same time, you need to optimize the fuel cell. So the problem objective here is to maximize the benefits to the microgrid operator by minimizing the line losses and the operational cost of the fuel cell and maximizing the stored energy. So at the end of the day, the overall objective function will be like you need to minimize the losses, right? The minimum of the load into the efficiency factor will come into the picture, and since there are two fuel cells that is added to that, and which is subtracted from the stored energy into efficiency of the storage. So this will give the losses. What is the value of the loss you are going to incur in the system? But what happens is, however, the line losses associated with each of them are different. So the problem further extended by letting URFC systems operate independently now becomes the. I think there is a cut down. 1 second. Okay, so in both the scenarios, load flows is carried out by calculating the line losses. So, however, before calculating the line losses, the URFC operation at each hour of the day should be known in advance. Since you have forecasted the load, so you'll be knowing at what point my fuel cell is going to charge or discharge, right? So that has to be optimized depending on your load schedule. So these are the techniques we have used to optimize break-even analysis approach, and we also use genetic algorithm and simulated annealing, particle swarm optimization, and backtracking search algorithm. You can also find the paper on this. We recently published this in IEEE transaction. Using this all algorithms, we optimized the microgrid with minimal losses. The last 4 techniques, what I've talked about, they come under evaluatory algorithms, which are inspired by the process occurring in nature, while the first method, break-even analysis, graphical approach. The genetic algorithm and the particle swarm optimization are related to the natural process which you daily see in day-to-day life. So these are the simulation results we got. The break-even analysis approach and heuristic optimization algorithms, along with the backward forward sweep load flow calculations implemented on microgrid network, and the value objective function from break-even analysis at all considered efficiencies in shown in table. Like you can see the table here with 50% fuel cell efficiency, with 70% fuel cell efficiency, and 80% fuel cell efficiency. So as the fuel cell efficiency changes, the value function using BC analysis also changes. With 90%, you can see the minimal losses which are incurring, and also the optimized fuel cell what you can get here. So one disadvantage of BEC analysis is ignores the relation between the URFC operation and optimization, and the line. You need to consider the relation between the operation optimization of fuel cell as well as the losses minimization. To overcome above limitation, heuristic techniques are employed over load flow analysis to minimize the value function. The value function defines the losses value. The simulation results for both scenarios, like this. The scenario 1 and 2 are shown here. I'll show that graphs. So without URFC units installed in the network, only the line losses constitute the objective function. So for 24 hours, it comes out to be 1,857 units of line losses, which is far more than those obtained from the URFCs placed in the network. One second. Okay, the 2 scenarios what I'm talking about is in scenario 1, both the fuel cells operate in unison. That means they're operating depending on each other. Power flows curves are obtained from the various algorithms. As I said, we are used 4 algorithms with different system efficiencies. The curves include storage state, power consumption by each unit, and also line losses, and the power at the point of common coupling. Whereas in scenario 2, both fuel cell will operate independently, so the microgrid operator can take decision independently to control the fuel cells. So these are the power flow curves at 90% efficiency for scenario 4 algorithms. The first graph, you can see the state of power consumption by each unit in GA, SA, PSO, and BSA. The 4 graphs with four curves, with 5 curves you can see here. From these graphs, one can see the last 2 graphs you can see here. This is the power required at the power optimized using different algorithms. So
what is the first graph?
First graph is this is a genetic algorithm optimized thing.
The first graph is
okay. The first is the power consumption by each URFC unit.
Okay. And the second one?
Second is the PV generated power.
Okay.
And the third one shows the steps is the charging and discharging modes of not a supercapacitor of the fuel cell. We are not using supercapacitors in this. And the last 2 graphs shows the load and the forecasted thing, which is almost we are meeting at the end of the day with all this forecasting, all this optimization algorithms. This is a power flow curve for scenario 2. In scenario 2, 2 fuel cells operate independently. So the microgrid operator has the flexibility to consider whichever fuel cell you want to charge or discharge. This is for G and SA. I mean genetic algorithm and swarm optima. And the second is the BSA and PSO graphs. These two graphs shows the for different optimization techniques. So this is the value of the objective function we got at different efficiencies. As I said, it's clear that BSA gives a minimum value. The break-even analysis gives a minimum value, which is, you can see the 90% efficient thing, the scenario 1 and 2. The BSA gives the minimal line losses, 8070 and 8085, compared to the all other algorithms, the optimized algorithms what you have predicted. Since the practical operation is yet to, we haven't got the data of a complete year for this project, so we need to check the results with the practicalities and what we have actually forecasted here. But as of now, the 2-3 months data what we got from the operator, which is similar to the what we are expected from this thing. Coming to discussion of this project, we have done a completely different approach is brought in here by taking into account of time of use, like the tariff model. For example, this is, since it's an isolated grid, there is no demand optimization thing. Demand, what you say in smart grids. If we integrate that into this model would be the path leading to microgrid optimization comes into existence. The objective function formulation seems to be simple, but when it comes to mathematically, you need to solve it. The traditional approaches fail. So you need to have complex mathematics involved into this, because there's multiple local minimas, which renders the conventional techniques from finding the global minimum. So we used heuristic optimization algorithms where we adopted to resolve the complexity related with this problem. And the method is applicable to any network. In this case, we have considered 2 power generation sources and 2 fuel cell units, but generally this is not the case. Happens in day-to-day grids. So we can replicate this model with any number of bus systems and storage units to come to this objective function. The solution minimizes the objective function by scheduling the operation of URFC system for 24 hours based on the load and weather forecast available. So again, this system becomes simple if you have a proper forecasting for load. If you have a load forecast which is very accurate in the range of 5 to 10%, you can easily predict the fuel cell operation. So there will not be any lag in the systems. Coming to a future scope, the problem formulation is unique and itself, and different solution methodologies have been adopted, which improves the result. However, the exact nature and the complexity of the problem still remains unknown. We are still yet to identify some of the complexities that going to occur. So we are hoping this will get the expected results what we analyzed from this. And there is a huge scope. One need to understand the complexity and nature of objective function, and in suggesting other methods which are suitable for such kind of problems. So coming to the research areas, what we are working on, we generally, our company enables renewable energy education and research through our innovative products and solutions. So we have emphasis on usage of renewable energy sources. We also conduct solar training camps for students and professional and academicians. We have R&D lab, which is in-house for polytronics converters, useful for harnessing solar PV and wind power. And we have renewable energy R&D support from all the IITs, since the complete R&D team what we have all are from IITs and other institutes. And we have set up laboratories in almost 300 colleges till now. And also we have renewable energy curriculum development we generally do in many of the institutes. And we are committed towards facilitating professional students with higher end configurable solar and wind related research products. So we have started the company in 2010, which is 5 years back. And our first product got in 2011, and we developed a training lab in 2012. And by 2013, we have almost more than 100 plus clients. By 2015, we are developing complete new set of labs for renewable energy. So why we are doing this, and why there is a reason behind this. Less than 4% institute offer course in energy and RE. Less than 1% of the manpower demand was being met by the formal training infrastructure. So hence it becomes imperative. So every institution has to impart this renewable energy so that the concepts will help more than 20,000 students across the country every year. So we have facilitated indirectly jobs to more than 20,000 students across India every year. So coming to the energy labs, what we are discussing about the research areas we develop is we have 3 labs: wind power generation and research lab, solar photovoltaic research lab, and solar thermal research lab. Whereas in wind power research lab, you can see the 2 products we have. Wind turbine energy training system, where you can learn the concepts of cut-in speed, cutout speed, and active power, reactive power from wind energy sources. And we have wind emulator. So if you want to do a research on wind energy output, for example, if you want to do research on 2 kilowatt wind turbine, you need not go and buy a wind turbine physically and get into the lab, and you need to get the wind profile and you need to generate the energy. So this wind emulator mimics the characteristics of a wind turbine, and you can get 3-phase output, which you can control at different wind speed. So if you want a wind speed at 4 meter per second, you just give an input of 4 meter per second in the interface we are providing. It will generate a 4 meter per second output. If you want to control the pitch angle of a wind turbine using your own algorithms, or depending on the forecasted climate, you can also do that. And coming to the solar photovoltaic research lab, we have 3 products. The basic one is the training system, where one can train different concepts, like you can learn the PV IV curves, and you can also feed your own algorithms for MPPT tracking. So if you are doing research in multi-MPPT mode for a power plants or for an inverter, you can actually feed the algorithms into the system, and you can evaluate your algorithms as a test bed kind of thing. And the second thing is a grid-tied inverter, solar PV grid-tied inverter training system, where you learn the concepts of grid synchronization. So how the synchronization happens, what are the current Indian standards to follow the synchronization, what are the THD levels you need to obey to synchronize with the grid, and the concepts like net metering. What if you have a surplus power, you can feed into the grid, and if you are deficient of power, you can take from the grid. So that net metering concepts can be learned from this thing, this product. And the third is a solar PV emulator, where you can mimic the characteristics of a solar PV panels. So if you want to get the characteristics of a PV panel in Chandigarh, or if you want to get a characteristics of a panel in Tamil Nadu, so you can, by sitting at the lab, you'll get this characteristics physical output, like the voltage current of any module or any manufacturer or any location globally, you can get at your lab, so that you can do research at the output of the system by testing your inverters, or testing your MPPT algorithms, or you're testing your charge controllers. So the research areas are many things you can do from the system. And the third,
in the emulators, the response, like you said, if I want a PV response for Chandigarh, so is it instantaneously fed to the system, or according to the past history?
So if you want to get the data for tomorrow, for example, how my plant is going to behave tomorrow, so you need to give the date of that for that location, for that date, at what tilt angle, at what kind of surface you are putting up your plant. If you are placing it on a roof, or you're placing on a ground mounted, so it will be instantaneously. It will be instantaneously. We have integrated the server with NASA weather data. So what does it do? The algorithm forecasts what will be the data for tomorrow by considering the past data as well as the predicted data from different areas. So depending on that, it will give a physical output. So you can, if you want to test the module in summer, winter, or if you want to test the module in Rajasthan, where the ambient temperature goes beyond 60-70 degrees Celsius. So in that case, how the module efficiency is going to change. The module gives the performance different in Delhi and different in Rajasthan.
Based on the past history
as well as the
instantaneous
data. So you'll get the physical output. For 1 hour, you'll get the 3000 outputs.
Same for the wind as well, right?
Same as the wind.
Okay.
So the last lab, I'm talking about the solar thermal research lab, where you learn the concepts of solar thermal energy generation, storage, and application. We have solar concentrator system. We have solar flat plate water heating system, and third is a storage system, which is a thermal battery. So in this, all the three systems, one can generate energy and store using some phase changing materials like paraffin wax, fatty acid. So using those phase change materials, one can store the energy for 15 to 20 hours. I mean the heat energy in the form of heat, and then later they can collect that heat to use depending on their application. Whereas in concentrator, you can learn the concepts of solar concentrator, which are used in huge power plants, where you can directly generate the steam, and you can use to run the turbines in steam power plants. And the third product is the solar thermal training system, which replicates a solar water heating system you can see in your household applications. You can so in solar thermal water training system, one can actually change the insolation. So if there is a sudden change in insolation, how the system is going to behave. If there is a wind on the flat plate collector, how the losses is going to change. This all things can be manipulated. This all things can be changed, and you can actually see in the control unit we are giving this. And you can also integrate data logging into the system, so you can record the data and do your analysis for your research purpose. So by deploying all these products, you will get a hands-on experience to put up, to ready to install in the power plants, and what are the complexities and problems you're going to face while installing and troubleshooting. You'll all see and feel by using these all products. So as I said, these products can be useful for basic learning of solar and wind, and this catered to the needs both engineers and advanced learners. And there are different modes of operation in the system. You can manually operate, or it can also operate with computer interfacing. And this can also be configurable and can be extended depending on the application. Like the concepts of smart grids and centralized and smart controller for different sources can be developed. And as I said, the algorithms, if you have developed your own algorithms, you can burn into these systems and you can evaluate the performance of the systems, and then you can go for the large scale using the same systems. And the pilot project for smart grid using RE sources as distributed generators can be carried out. Since you have different kinds of generation at your end, so you can develop a DC microgrid or AC grid, microgrid, and you can also integrate with smart metering concepts into that. So these are some of the achievements. As I said earlier, we have more than 200 central universities, state, where we have installed these products, and many publications, research publications are also being done using some of our products, and 30 to 40 research options are available, as I said. And these are some of the clients. Almost all IITs and NITs are using our products, and they are day to day they are developing research, and they are giving feedback and input to us to explore more in this area. Thank you.
Under what name are your research papers?
Sorry?
Your research papers in IEEE transaction you mentioned.
Right.
Is it by what name, or what is the author?
That few are in the name of company name, EcoSense. Right? You can search on that.
Good afternoon, sir. I am from Rajasthan Technical University.
Okay.
Sir, if I want to establish a microgrid for a village,
okay,
so your company can help to plan all these things?
Definitely, we can help you out. Which area are you looking for?
Rajasthan.
Definitely, we'll definitely work on that. You can see my mail ID on the screen, right?
Ecosenseworld.com.
Right. You can write a mail to me, right? So that I can definitely help you out. We can size the system depending on the application you're looking for.
Not like a commercial project. It's just a study project for B.Tech, M.Tech students.
Right. So what is the capacity you are looking for?
Capacity for 100 house village. A
Okay.
village of 100 house.
Right. I mean to ask what is the power capacity you are looking for?
Power capacity, I think it is required 1 megawatt operation.
1 megawatt. Oh, that will be a huge plant. Then definitely we can size it out. For 100 homes, you are saying like it won't go up to 1 megawatt. To my knowledge, it will
100
be
also villages which has
okay. 100 villages. Okay.
which has no refrigerator and other air conditioner and all these things. So
Definitely.
basic only this.
We can carry out a load flow analysis. Then later we can size the system depending on the usage.
Okay. Thank you.
Okay.
Sir, one more question. Okay. So I am Bharat. I want to know which software you have used to solve that optimization problems in the hybrid system you have explained.
MATLAB and LabVIEW.
Okay. Thank you.
Sir,
Any more questions?
good morning, sir.
Yes.
I am from IC Engineering College, Greater Noida.
Sorry.
I have a question.
Yeah. Please.
Is IR radiation harmful for PV cells?
IR
Is
radiation.
IR radiation harmful for PV cells, and how we can protect PV cells from this kind of radiation?
No, PV cells has an encapsulant. You might heard about that, right? Is my voice audible?
Yeah, sir.
Encapsulant actually protects the PV cells from different kinds of radiation. May not protect completely. Depends on the polymer you are using in encapsulant.
Your voice is not. Your voice is not so clear, sir.
I'm saying you might
Your
have.
voice is not so clear, sir.
Is it audible now?
No, sir. Hello.
Hello. Is it audible now?
Yes, sir.
I'm saying you might have heard about the encapsulant, what we use on PV cells.
Yes, sir.
So the encapsulant actually provides from soiling as well as this different kinds of radiations. So if you are designing a polymer which can protect completely the IR radiations, you can go for that. But currently 80 to 90% of protection is we are getting from the encapsulant.
90%, not about 100%, huh?
No, not 100%.
Okay, thank you, sir.
Hello, sir. This is Devabrata Mukherjee from RTU. You have told about fuel cell. We have got the idea, but what is utilized regenerative fuel cell? I've not got the idea of that. Please.
You utilize regenerative fuel cell. Normally, what you get in the market is only generators which can only generate the electricity, right? The fuel cell stacks you can see in the market. In this regenerative fuel cell, we use a metal hydride. Okay, the metal hydride consumes electricity and it will generate the hydrogen, and it will feed into the fuel cell as and when required.
Okay, thank you.
So it's a both way operable. So you can generate and you can charge as well as discharge. What I mean to say, it's like a battery.
By the use of supercapacitor and battery also.
By the use of battery and supercapacitor.
You told now that we can charge and discharge. I mean to say that by supercapacitor and battery, the use of these two components, we can charge and after that use it as a URFC.
No, this is not the supercapacitor and battery. What I mean to say is, it's like in isolated areas. If you don't want to deploy batteries, okay, you can use this regenerative fuel cells. That means when there is a surplus generation from photovoltaic plant or wind plant, you can store the electricity in the form of hydrogen fuel. Okay, and when there is a deficient, the fuel cell will generate energy using the hydrogen fuel. Okay. You are generating hydrogen fuel from different sources. That is what I mean to say.
Okay, thank you.
Any more questions?
Hello.
Yes, tell me.
Hello, sir. I'm from RD Engineering College. I want to know how much fuel cell is efficient over normal battery.
Normally, normal thermal plant.
Efficient up to 65.
Almost
65%.
65%. Okay. DC converter. And I want to also know what is DC-DC converter.
DC-DC converter.
Yeah.
So suppose if you want different voltage applications, like your fuel cell will require a 12 volt supply for recharging. Suppose if you have a battery which require 20 volts for charging, and if you have a load which require 120 volts, the DC bus, so you need to have a DC-DC converter which can boost the voltage or it can buck the voltage. What I mean to say is your generation of voltage is at a different level and usage of voltage is a different level. So you need to have a DC-DC converter in between to do this function, which can also be controllable.
Hello.
Hello.
Hello. I'm gonna basically it is a amplifier.
Right. You can say it will not only amplify.
Okay.
It will also boost what I mean to say.
Okay. Thank you, sir.
Any questions? Okay, thank you. If you have any queries, you can drop your queries at my email. It's rmuthyal@ecosenseworld.com. Thanks for your patience.
Is that
rmuthyal@ecosenseworld.com.
EcoSense World.
Yeah.
मेरे को फोन है. Hello. Hello, Ritu from Modi University. Ritu.
Hello, ma'am. Can you hear me?
Yes, I can hear you.
Okay.
But I cannot see you.
Wait a minute, ma'am. ठीक है ना?
Yes.
Hello, ma'am.
Yes.
Ma'am, can I give a feedback right now?
Yes. बताओ.
Okay. A very good afternoon to all of you to this validatory session of short-term course that has been conducted in association with NITTR Chandigarh over the last 5 days. We have had a deep insight into this STC course. I would like to thank NITTR Chandigarh and Dr. Linny Matthew for organizing such a wonderful STC course on smart grid and renewable energy sources. From this course, participants gain a knowledge in the emerging and upcoming field of smart grid. One of the lecture of Dr. Mukesh Singh regarding hybrid electric vehicles, that was very interesting. One thing I want to say that the objective of the STC course is to acquaint participants with MATLAB and Simulink for simulating power systems and energy sources. That was not fully achieved by anyway the course was very informative and knowledgeable. And finally, I thanks to all the faculty members who keep faith on us and attend this course wholeheartedly and sincerely. I now respect Professor Manish sir for giving the feedback of this course. Please, sir.
Good afternoon, ma'am, and good afternoon, everybody. I'm Manish Kumar from Modi University. The whole session was very informative and very knowledgeable. Okay, but I think, madam, it was based on basically for only for student because I am associated with the smart grid from last 2 years. Therefore, I was expecting more research oriented. Some lecture was very good, definitely very good, like the lecture given by Dr. Mukesh Singh from Thapar University. He gave in his last lecture, last slide, something about the research, and the lecture given by cyber security also it was good.
Dr. YP Verma also gave you some ideas on research.
What, madam?
Dr. YP Verma, when he was talking on microgrid also, I told him to give him some insight on research.
Okay, madam.
That he also gave you.
One thing, madam, I want to add here. One thing I want to add here. If you will give this idea, suppose we want to set a 1 megawatt power plant, especially rooftop power plant, then what is prerequisite for us? Then I think it will be help for our university also, and it will be great help of our nation also.
Yes, I'll tell you, because we have a 30 kilowatt power rooftop system on our, we have it in our institute. So
okay, very nice, madam.
Dr. Poonam Sial also only was the in charge of it. I thought she might have given it to you. You can contact her, Poonam Sial.
Okay,
Dr. Poonam Sial, she will give you the details of all the whom to contact. You know, you get subsidy from the government. So
Yes,
you see which state in Rajasthan who is coordinating it, because we are getting it from Chandigarh. Crest, we have an organization here and we are getting the subsidy from there. So we have to write to them and get it. So what all is required is done through them only. So from Rajasthan, you have to find out who gives the subsidy and what are all the procedures to do that.
According to my knowledge, Rajasthan government is also giving about 70% subsidy on this. Okay. Why I'm saying, because I think 10 colleges are associated with this program, and all college has, I think, a lot of space at roof, and that is no use. Then set up a rooftop model of a solar power plant, then it will be great help of our nation also. Okay, and student can also simulate or he can take the data, he can experiment from that data. I think I just give you one example. IIT Mumbai has 1 megawatt rooftop solar, and he is especially using that rooftop for generation with experimental. So therefore, this will be a means
So
great thing.
now what you do is when you go for subsidy and all those things now, maybe that facility they may not give. We that problem we also had here because
Okay.
we did it we did it from Crest, the organization who gave us subsidy. Now what they did, they have installed it, generation is there, everything is there, but then we cannot do anything for research over there. So that you have to specially discuss with them and find out the details to how to get the data for research. Otherwise, they will install. We also did not remember that we have to do that also. What you are saying, IIT Bombay had done it. It is good. So what we are planning is we are going for more rooftop, which will give us the data also. Data,
Okay, thank you, madam.
if you want to really get the data, you have to discuss all these things from the organization who is giving you, giving you the subsidy and who is installing it on the rooftop.
Okay, thank you, madam. As my knowledge, smart grid is in primary level. Therefore, it was a means great session for the student also, and there is MTech student also here. After completing MTech, they can go for the PhD for in this particular year. Therefore, I think this is a great session. Thank you. Thank you very much.
Give me the list. Please send me the list of the students when you send list of students who attended.
Okay. We will send, madam. No problem. Okay, I will send the list of the student. Okay, thank you.
Okay, thank you very much.
Thank you
Anyone
very
else?
Good morning, everyone.
Yes.
Good afternoon. Sorry.
Good afternoon.
I am Pratishtha Gupta from Modi University. Looking at the importance of smart grid and renewable energy resources, this 5-day workshop emerges as a boon to electrical engineers. This workshop magnified our view towards the renewable resources and the scope of smart grid and its necessity to install in our country in order to reduce carbon emission in a smart way. We get to learn about HEVs, which will one day or the other will replace IC engine vehicles to make world survivable. I would like to thank NITT Chandigarh for organizing this workshop. Thank you so much.
Thank you.
Good afternoon, everyone. This 18 to 22 January workshop objective is to enhance the knowledge of the participants in the area of smart grid and renewable energy, a unique opportunity which delves into the microgrid, generated power system stability and power quality, hybrid electrical vehicles, etc. And importantly, how this can be done in intelligent and cost-effective way. This workshop will provide a platform to an in-depth discussion on the various challenges and their possible remedies which will benefit engineers of utilities and policy makers and institutions. Thank you, ma'am.
Thank you.
Okay, thank you, ma'am.
Thank you. Jitu, I wanted to tell you is you please send the list of participants and all the bills fast. Okay, yes, don't delay it because I have to process it faster here. And all the list of students who attended specially.
Yes,
as a separate list, you give the list of the students attended also.
Okay, ma'am. Thank you.
Okay, thank you very much. Okay.
Thank you.
What program you are having today in the afternoon?
Ma'am, actually, today after cultural program, that is the FDC program, Founders Day celebration of our college.
Okay. Okay, thank you very much.
The 5-day programs actually from 22 to 26.
Okay, so today is the starting.
Yes, ma'am.
Okay. Okay, thank you very much. Thank you very much. Other senders have been disconnected, I think so. Okay, we will meet. Hello.
Good afternoon, ma'am. I am from IEC College of Engineering Technology. Professor Mahavi Singh Naruka is there. Hello.
Yes. Yes. Follow.
Yeah, ma'am. Some of our participants wants to give the feedback for.
No, it is not the feedback time now. The feedback you give in the afternoon only. Only for Modi University, because they will not be available in the afternoon. They have some program in their institute. They have done it now.
Okay.
Just I heard it from them.
Yeah.
You come by 2:30, 2:15 you connect, 2:30 we will have the valedictory function and I will listen to you. All my other faculty members also will come. We will sit together and listen from all of you except Modi University. They have specially requested me to have it just now, see, listen to their feedback now. Okay, no problem. You come by 2:30. Okay, we will start again at 2:30. Okay? Okay.
Thank you.
Okay. Thank you, Prasanna.
Confusion हो गया है।
Yeah, no? Can I take this?
Yeah.
జీవన పర్యంతరం అఘోరం ఆ లైన్లో మాత్రమే అఘోరం ఇప్పుడు అఘోర కావలి దాని తర్వాత 2-3 రోజులు దీక్ష చేసేవాళ్ళు, ఇలా జీవిత పర్యంతం చేసేవాళ్ళు. అలాంటిది నేను జీవిత పర్యంతం ఆ దీక్ష కొనసాగించాను.
ఏం ఉండదు, ఏం చెప్పట్లేదు. టీవీలో చూసాను ఆల్రెడీ, ఇంకా రాలేదు ఇల్లు. సరే అన్న ఒకసారి పైకి వెళ్ళి వస్తాను నేను. ఏదో ఈ ఒక ఈవెంట్ కి మనం కోఆర్డినేటర్ ఎనర్జీ కన్జర్వేషన్ మీద పోయినసారి జరిగింది, అయిపోయింది కదా. నెక్స్ట్ ఇంకోటి 31st జరుగుతుంది కదా వర్కింగ్ పిల్లల దగ్గర నుంచి కొంచెం డేటా కలెక్ట్ చేసి తొందరగా వస్తే నేను వెళ్తాను. నా క్లాస్ ఎన్నింటికి? 2:20కి క్లాస్. నేను 2:10 కల్లా వచ్చేది. 2 అయిపోయింది, 10 minutes వచ్చేది. పైకి క్లియర్ అవుతుంది. ఓకేనా? రండి.
అక్కడ బీరు తాగుతూ ఏడుస్తూ కూర్చుంటే అడిచి మెడలో తాగు కడతారా? ఏదో ట్రై చేయాలిగా.
ఏం చేస్తాం, అమ్మాయిలు జెన్యూన్ గా లవ్ చేయడం ఏంటి
చెల్లికి వస్తే కదా ఈ పేరు మీద స్టేషన్ లో పిలిచి వదిలేస్తావా? ఇప్పుడు మా అక్కకి ఇవ్వడం కోసం కొంత టైం ఇచ్చేయండి, మీ చెల్లికి ఇవ్వడం కోసం ఎక్సలెంట్ ఇచ్చామనుకో, నాకు నేను ఇష్టం లేదు కాబట్టి నాకు తిరిగి ఇచ్చేస్తాను, నేను మళ్ళీ తీసుకొచ్చి నీకు ఇచ్చేస్తాను, మళ్ళీ మా అక్కకి ఇచ్చేయచ్చు. మరాఠీ సినిమాని భోజ్పురి సబ్ టైటిల్స్ తో చూసినట్టు. అంకుల్ మిమ్మల్ని అందరినీ వదిలేసి వెళ్ళినప్పుడు మీకేం బాధ అనిపించలేదా?
ప్రతి భార్యలాగే రోజు భర్తకి వండి పెట్టాలి, శనివారం అయితే కలిసి గుడికి వెళ్ళాలి, పక్కనే ఉండాలి, అన్నీ చెప్పుకోవాలి. కానీ వాటన్నిటికంటే పిల్లల మీద ఆయనకున్న బాధ్యత ఎక్కువగా కనిపించేది.
అతను హీరోయిన్ ఎవరు సార్? సైన్యం లేదు, యుద్ధం జరగలేదు, చేతులు వెప్పని కూడా లేదు.
ఇంకొక అతను
సంతోషంతో తోచింది.
ఇలాంటప్పుడు మెడిటేషన్ చేస్తేనే బాబు మనశ్శాంతి కలిగేది.
మనసు దాని దగ్గర ఉండే శాంతితో నేనేం చేసింది
మనసులో ఉన్నది ఎవరికైనా షేర్ చేసుకుంటే
ఇవన్నీ డిలీటెడ్ సీన్స్ అంట, సినిమాలో నుంచి డిలీట్ అయిన సీన్స్ అంట ఇవన్నీ.
ఇక్కడ మాత్రం యూట్యూబ్ వస్తుందా?
ఇది టోటల్ 100% వర్షన్ ఇన్ నెట్.
సిటీలో పెళ్లి గురించి అటు ఇటుగా చేస్తున్నారు.
స్ట్రీమింగ్స్
సో ఈ పెళ్లి సంగీతంతోనే స్టార్ట్ చేద్దాం.
చాలా తీసాడు, ఇందులో గుర్తులేదు మరి ఎవరు రాలేదు, వస్తారే ఉన్నది.
వస్తే క్లోజ్ చేసేయండి. అదేంటి సార్ అది? అది
యాంప్లిఫైర్, అది స్పీకర్ యాంప్లిఫైర్.
ఇట్లాంటి యాంప్లిఫైర్ ఎప్పుడు చూడలేదు నేను.
మన కింద ఉంటాయి మన దగ్గర కూడా.
ఎవరి దగ్గర కొన్నారా దీనికోసం అంటే వేరే వాళ్ళు దీనికోసం క్రౌడ్ వస్తున్నారు క్లోజ్ చేశారు.
పైకి వెళ్ళారు. స్టూడెంట్స్ డీటెయిల్స్ ఏవో తీసుకురావాలంట కదా, దానికోసం వెళ్ళారు. బజ్జీ తింటారా మీరు? బజ్జీ నేను మీ సార్ మెడిటేషన్కి వెళ్తున్నారా?
ఈ మధ్య నా ఫోన్ పడలేక కొంచెం లెక్కించాను.
ఎందుకన్నా
మార్పు కనిపించలేదు. మామూలుగా అయితే నెలకు 10 రోజులు ఖచ్చితంగా వెళ్తారు. మ్యారేజ్ కాకుండా అయితే ఖచ్చితంగా వెళ్ళేవాళ్ళు. మ్యారేజ్ అయిన తర్వాత 2 months పిల్లలు పుట్టిన తర్వాత మ్యారేజ్ చేయడం 10 రోజులు తన గౌరవం కష్టం ఉంది. తను కొంత రియలైజ్ అయ్యారు. జాబ్ కోసం చెన్నై వెళ్తారు, కొంత రెస్పాన్సిబిలిటీస్ వెళ్తానని అంటున్నారు. కానీ నేను ఇండైరెక్ట్ గా వాళ్ళ వెళ్ళేదానికి లేదు. చెన్నైకి కాదు, కంప్లీట్ గా నేను ఇటు సాయిబాబా గుడికి తీసుకెళ్తాను, వెంకటేశ్వర స్వామి గుడికి నా ద్వారా కాకుండా దాని అన్ని ఉపయోగం. అంటే నేను తీసుకుంటున్నాను బాగానే ఉన్నాను. ఎక్స్ప్లెయిన్ చేయలేదు. నాకు ఆ అభిప్రాయం ఇలా ఉంటారేమో.
Goes inside out. He's sailing in sixes at the moment. Such powerful wrists, especially when you take the distance he's got here. Number 4 over the boundary for Estonia.
IPL CFT.
Just a bit loose on. That is great.
మీరు మీ ఫోన్ ల్యాప్టాప్ పెట్టుకున్నారు.
Power as you get into the circle.
అంటే రజనీకాంత్
leg. Massive, misses the finish.
సాయిబాబా కూడా గురువే ఆయన.
It will be the biggest of the Champions League so far.
ఒక లైట్ వెలుగుతూ ఒక ఆయన మాట్లాడతారే రజనీకాంత్, ఆయన
And the third six of the over. Let's see how many meters this is gone.
Equal to Saint Clark. Saint కంటే
in height and in distance, 101 meters. The biggest. And it's in the red zone.
మహాత్ముని సృష్టించిన
See the biggest six is 101 meters. 4 sixes in this over, but it's still 1 more to go. This is the second. Number 3.
అంటే ఎక్కడ అడ్వర్టైజ్ గురించి తెలియడం కానీ బాబా మూవీ చూసిన తర్వాత తెలిసింది.
బయటకు వచ్చేది లేకపోతే బయటకు వచ్చేది కదా, అది కూడా ఆయన పర్మిషన్ ఇవ్వటం వల్ల వచ్చింది.
ఎవరు వచ్చారు?
బాబాజీ బతికున్నారు మలేషియాలో ఉంటాయి. యాక్చువల్గా చెన్నైలో పుట్టింది. అగస్త్య మహర్షి తపస్సు చేసిన ప్లేస్లో చేశాడు ఈయన. మన సౌత్ ఇండియా మొత్తానికి అగస్త్య మహర్షి వల్లే శివుడు అంటే ఏంటో తెలిసింది, ధ్యానం అంటే ఏంటో తెలిసింది, యోగం అంటే ఏంటో తెలిసింది. ఈ సౌత్ మొత్తం అంతా అగస్త్య మహర్షి సంబంధించినవే. ఇప్పుడు మనం కూడా ధ్యానం గురించి మాట్లాడుతున్నామా లేకపోతే ఒక దైవం గురించి మాట్లాడుతున్నాం అంటే ఈ ప్రేరణ అంతా కూడా అగస్త్య మహర్షి. ఇప్పటికి ఎలా కూడా ఆయన మహర్షి లేదు, అది రోల్. వ్యాస మహర్షిది రోల్, పర్సన్ కాదు. పర్సన్స్ వేరు, రోల్స్ వేరు. సప్త ఋషులు అనేవాళ్ళు పర్సన్స్ కాదు, రోల్స్ అయ్యి. సప్త ఋషులు మనం ఆ స్థాయికి వెళ్తే పర్సన్ మారిపోతూ ఉంటాం.
మనం ఏదో వాక్యాలు ఏదో చదువుతూ ఉంటే అందులో నుంచి సృష్టించబడ్డ వాళ్ళు ఏదో సప్తపురుషులని ఎక్కడో చదివితే ఎక్కడో వేరే వాళ్ళు
ప్రతిదీ దైవంతో సహా మనమే సృష్టించింది. మనం ఏం చేస్తామంటే మనం ధ్యానం బాగా చేసిన
అవతార్ బాబుతో
కమ్యూనికేషన్
ఫేస్ టు
ఫేస్ మాట్లాడతారు. మహాత్మా బాబాజీ ఆయన్ని కలుస్తాడు. లేకపోతే రజనీకాంత్ చేసిన పనులు మనుషులు ఎవరైనా చేశాడా చెప్పండి? బోల్డంత మందికి బోల్డంత డబ్బులు ఉన్నాయి. రజనీకాంత్ ఇంటికి వెళ్ళి నాకు డబ్బులు కావాలి అని అంటే నువ్వు ఎవరో నీకు ఎందుకు కావాలని కూడా అడగడం, తీసి అలా ఇస్తాడు. పలానా హాస్పిటల్లో ప్రాబ్లం ఉంది, డాక్టర్స్ లేరు అని అంటే ఇమ్మీడియట్గా ఆ డాక్టర్స్ తెప్పించడానికి ఎంత ఖర్చు అవుతుందో అంతా బేర్ చేస్తాడు. సినిమా ఫ్లాప్ అయిందంటే ఆ డబ్బులన్నీ ఇచ్చేస్తాడు, తీసుకోడు. అరుణాచలం అని ఉంది, తిరువన్నమలై కొండ చుట్టూ పౌర్ణమికి తిరుగుతారు. ఒక పౌర్ణమికి జనాలు లక్షల్లో వస్తారు. అది రాళ్ళు గుచ్చుకుపోతున్నాయి మట్టి అని చెప్పి గవర్నమెంట్ కూడా రోడ్డు అయ్యా రజనీకాంత్ తెప్పించాడు రోడ్డు కొండ చుట్టూ. సో ఏంటంటే మహానుభావులు ఎలాంటి వాళ్ళకి కనిపిస్తారంటే ప్యూరిటీ ఆఫ్ హార్ట్.
అంటే మనం లాంటి వాడు వెళ్ళి ఆయన చూడలేదు, అంటే మనకు కనపడదు,
ఎట్టి పరిస్థితుల్లో కనిపించరు. మీరు మీ కళ్ళు మూసుకోండి ఒకసారి. ఇప్పుడు ఏమి కనిపించినాయి?
ఏదో వెలుగుతున్నట్టుగా ఉంది.
ఎక్కడి నుంచి కనిపించినాయి? ఈ రెండు కళ్ళకు కనిపిస్తున్నాయి. అవి ఎందుకు కనిపించట్లేదు? ఈ రెండు కళ్ళు మూసినప్పుడు ఆ వెలుగులు ఎందుకు కనిపించినాయి? ఒక్క సెకండ్ కూడా కాదు, నానో సెకండ్ మీరు కళ్ళు మూసుకుంది. ఎందుకు కనిపించింది? మనకు 3 రకాల కళ్ళు ఉంటాయి: చర్మచక్షువు, మనోచక్షువు, జ్ఞానచక్షువు లేదా దివ్యచక్షువు అంటారు. మన శరీరానికి అతుక్కొని ఉన్నాయి కాబట్టి ఇవి చర్మచక్షువులు అంటారు. ఓకే, మనం అలా మూసుకున్నప్పుడు మన ఫ్రెండ్స్ గురించి కానీ, మన తల్లిదండ్రుల గురించి కానీ, పిల్లల గురించి కానీ, వాళ్ళ గురించి కానీ, వీళ్ళ గురించి కానీ ఏమైనా జ్ఞాపకాలు వచ్చినా, లేకపోతే వాళ్ళ ఫోటోలు కనిపించినా, ఏదైనా చేసినా మనోచక్షువు అంటారు. మనకు తెలియకుండా కనిపించే వాటిని జ్ఞానచక్షువు లేదా దివ్యచక్షువు అంటారు. దానికి ఉదాహరణ శివుడు. శివుడికి ఎప్పుడు థర్డ్ ఐ ఉంది అంటారు. థర్డ్ ఐ ఈజ్ నథింగ్ బట్ అదనమాట. జరగబోయేదంతా తెలుస్తూ ఉంటుంది కానీ ఏమీ చేయలేడు.
అంటే అంత చీకటిగానే అక్కడక్కడ లైట్లు
ఎలా కనిపిస్తున్నాయి? ఈ రెండు కళ్ళకు కనిపించినాయి, అక్కడ ఎలా కనిపించినాయి? కళ్ళు మూసుకున్నప్పుడు ఎందుకు కనిపించినాయి? అది కూడా నిద్రలో కనిపించవు. మళ్ళీ ఎందుకు కనిపించదు?
రీజన్స్ ఉంటాయి.
అది ఏంటంటే ప్రతిదానికి రీజన్ ఉంటుంది. మనము పూజ ఎలా చేయాలంటే, పూజ చేయాల్సి మనం ఎలా ఉండాలి అంటే,
వాళ్ళే వ్యాలిడేట్
క్లారిటీ రావట్లేదు. ఇవన్నీ
పర్సనల్ ఒపీనియన్ ప్రకారం జనరల్ గా మీరు అన్నారు మహా అవతార్ బాబా అని. ఆయన ఏంటి మెడిటేషన్, పీస్ ఆఫ్ మైండ్, పీస్ ఆఫ్ సోల్ అన్ని కంట్రోల్లో పెట్టుకోగలిగారు. సాటి మనిషిని హట్ చేయకూడదు, అలాంటి ఆలోచనలు ఉన్నాయి ఆయనకి. అందుకని ఆయన గొప్పవాళ్ళు. ఆయన ఫాలో అవుతుందో అన్నారు. ఆయన చెప్పినట్టుగా వింటే ఖచ్చితంగా గొప్పవాళ్ళే అవుతారు. కానీ నాకేం పెద్ద మార్పు కనపడలేదు సార్. మా వాళ్ళు ట్యాక్ పెట్టుకోవాలి అంటే తల్లి కంటే వైఫ్కే హస్బెండ్ నుంచి పర్సనల్గా అన్నీ తెలుసు. సో అందుకని నేను నా పర్సనల్ ఒపీనియన్, అందుకని దాన్ని ఆల్మోస్ట్ అవాయిడ్ చేయించడానికి 98-100% ట్రై చేశాను. ఇప్పుడు 2-3% మార్క్ ఇంకా కాకపోతే సార్ మా వారిని వచ్చేది ఏంటంటే వన్స్ అలా మెడిటేషన్కి వచ్చినారంటే 6-7-8 hours కూడా అలానే కూర్చుంటారు. అసలు అంత కాన్సన్ట్రేషన్ అనేది నాకు డౌట్, మీరు నిద్రపోతుంటారా ఏంటి అనేసి ఒకసారి అడుగుతాను. నేను నిద్రపోతాను.
గట్టిగా ఉన్నారు ఇంకా ఎంత 2 hours కానీ మనకు తెలియంది చాలా ఉంది మేడం. మనకు తెలిసింది ఏంటంటే ఒక పాయింట్ అంతే లైఫ్ మొత్తం మీద ఇప్పుడు దాకా ఏదైనా సరే పాయింట్ అంతే. మన ఎడ్యుకేషన్ కానివ్వండి, ఫ్యామిలీ పరంగా కానివ్వండి, లేకపోతే ఇంకేమన్నా అన్ని టోటల్ తీసుకుంటే పాయింటే. తెలియాల్సింది చాలా ఉందన్నమాట. విజయ్ రావట్లేదు, ఇల్లు స్టార్ట్ చేయండి.
ఇచ్చారా పర్మిషన్ చూపించిన సినిమాలో?
నీకోసం అనుకుంటున్నా.
అందరూ ఉండమని చెప్పారు సార్ ఫ్యాకల్టీని, అందరూ మాట్లాడాలంట.
సరే నేను వెళ్తున్నాను, క్లాస్ టైం అయిపోయింది.
ఏసీ వేసుకోవా? వేసుకో. గ్యాస్ స్విచ్ ఇక్కడ వేస్తే లేదుగా, ఇక్కడ ఆన్ చేయాలంట. సార్ కూర్చోండి సార్, ప్రశాంతం కూర్చొని చెప్తా. అన్న 2 A4 షీట్లు ఖాళీ ఉంటే ఇస్తావా? ఉన్నాయా? సార్ కేపీ సార్కి ఒకసారి ఫోన్ చేస్తా పోతుంది సార్. వాల్యుయేషన్ చీఫ్ గెస్ట్ ఉన్నాను సార్. లేవా? సరే సరే, ఓకే ఓకే.
తర్వాత వాళ్ళు ఏమేమి పంపించారు ఏంటంటే డీటెయిల్స్ ఏమి చెప్పారు ఇందాక?
చెప్పలా.
చెప్తారు మాకు చూసుకోవాలి సార్. ఈ షీట్స్ అన్ని స్కాన్ చేసి పంపించారా లేకపోతే డైరెక్ట్ పంపించాలి, ఏదో ఉంటుంది సంథింగ్. అవన్నీ షూట్.
గుడ్ ఆఫ్టర్నూన్ సార్. సార్ మరి ఇప్పుడు వస్తారు సార్, వాల్యుయేషన్ ఫంక్షన్ ఉంది కదా. ఓకే సార్, అదే సార్కి మార్నింగ్ చెప్పాను ఆల్రెడీ వస్తారా అని. మళ్ళీ మీరు ఒకసారి మీకు కూడా చెప్దామని ఫోన్ చేశాను సార్. ఓకే ఓకే ఓకే, సరే సార్. అలాగే తప్పకుండా సార్. ఓకే 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 సార్. మన సార్ ఖాళీగా ఉంటారో లేదో. సార్ ఫోన్ నెంబర్ అంతా హలో మేడం, సార్కి ఖాళీగా ఉందా ఇప్పుడు? అదే సార్ మరి ఒకవేళ
మీ దగ్గర డీటెయిల్స్ రాయకపోతే రౌండ్ ఆఫ్ చేసి డీటెయిల్స్ ఇవ్వండి అని చెప్పి పెట్టి మీరు ఏం చేయాలి? ఎక్కడైతే రౌండ్ ఆఫ్ చేసి డీటెయిల్స్ దానికి సంబంధించిన డీటెయిల్స్ రాయాలి. ఇప్పుడు అంతే రాసేసి నాకు ఇచ్చేయాలి. మేడం చెప్పి
మీరు ఉన్నారు కాబట్టి సార్ అడిగితే ఐడియా ఉంటుంది ఎవరు అలా చెప్పుకుంటారు. సిఎస్ అంటే మీరు కూడా అక్కడ ఉన్నారు కదా, మీరు అడిగితే
అన్న అది స్నాక్స్ గురించి అది అనుకున్నాం కదా, మరి అది చెప్తాం మరి ఫైన్ చేద్దాం. ఫోన్ మన వాళ్ళు అయితే 23 మెంబర్స్ రిజిస్టర్ అయిన వాళ్ళు మొత్తం మీద 23. ఓకే 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 ఓకే. ఎన్ని చెప్పండి సార్ బజ్జీ మొత్తం చెప్పండి సార్. 23 మంది ఇప్పుడు ఏం చెప్తారు అని వాళ్ళకి ఏం చెప్పాలి? మామూలుగా ఇప్పుడు మనం 30 బజ్జీ ఏం చెప్పకూడదు కదా, ఒక్కదానికి 2 ఉండి పెడతారు కదా. అలాగే సార్ 30 ప్లేట్.
क्या लिखवा दिया? दिखवा दी बिल्कुल सब कुछ दिखा देंगे यार, आप बोलो तो सही।
देखो हमारे दोनों कॉलेज के चक्कर में कि मेरे को तो यूजर नेम पासवर्ड की लेने की जरूरत नहीं पड़ी। जरूरत कहाँ है आपको? क्यों कहाँ पड़ा? है ना?
अच्छा देखो आप ही दिख रहे हो वहाँ
भाई साहब।
अरे तो यहाँ दिख रहा है, यहाँ तो नीचे
दिखेगा। इससे नीचे देखो मैन ऑफ द मूवमेंट, मैन ऑफ द मूवमेंट जिसने नीचे चढ़ाया भाई, इसको बंद करो। क्यों? वो आ रहे हैं कि
Hello, good afternoon. Can you hear me?
Yes, madam. Yes, madam.
Yes. Okay. So let us start with the valedictory session. One of my faculty members, Mrs. Shimi, is here with me, and the others are also joining. So let us hear from each of the institutes. As you all know, 1 week full we were listening. You were listening from me and various experts who were speaking from here. So now it's time for me to hear from you, your feedback and your suggestions, so that I'll improve this course. Regarding this smart grid, I should tell you this is the third course I am doing. One I did last year and two I did this year, and this is the first time I'm doing it on an ICT mode. So I require your suggestions where I can improve upon, and next time I feel that I'll do a course on contact mode where I can give you more practical exposures also. This time because it was an ICT mode, I did not go for practical exposures. So next time we can do that also, contact mode. So I want to hear your suggestions. So first I'll go to Moradabad Institute of Technology, Moradabad. Vipul Agarwal. If you have any guest at your place, you can introduce him also and give him also some time for speaking.
Okay. Good afternoon, ma'am.
Good afternoon.
Ma'am, it was a great experience to have this course in our college through ICD based mode.
Yes.
And I really request you to continue this for us. And I think I have just one thing to say. I want this course to be related to MATLAB also.
Yes.
Like we are talking about fuel cells, like we are talking about electric vehicles. So we must know about the modeling part. We must know about the fuel cell modeling part. So if it was so, then it was really very good.
Actually, you know, MATLAB is not a very effective software for smart grid simulation. There are other softwares like Homer or Opel RT. So we are in the process of procuring this. I told you now we are also doing this course for less time. We are also now finding out what are the various software simulations where we can do smart grid simulations. So I promise you next time whenever I do the course, I will help you giving other software simulations also of in regard with smart grid. There is no problem, we will be working on it, and next time when I do the course I'll do it in contact mode so that those who have attended the course now can come here and see all our facilities we have and the software and hardware simulations we do also. Okay, we will do that.
Thank you, ma'am. Thank you very much, ma'am.
Anybody else wants to speak from you, from Moradabad?
No, ma'am. Ma'am, thank you, ma'am.
Yes.
Ma'am, I have Dr. Farooq Hussain with me. So he want to say something.
Yes. You are from Moradabad Institute of Technology?
Yes, ma'am.
Myself, Dr. Farooq Hussain, I'm at Moradabad.
Yes.
This short-term course was very excellent, and we have learned a lot of things from these courses. And I would like to ask one question. Next program will be when is it start? Or the next?
I just wanted to know whether you want to know about the next program on smart grid or any other courses which we are doing.
Either in electrical engineering or electronics and communication engineering. So we are benefited.
We are doing two programs again consecutively like this from February 8 to 11, energy management, and then February 15 to 19 on soft computing, both on ICT mode. And we have a contact mode course from February 1 to 5 on embedded systems. So there are 3 courses next month from the electrical engineering department. One February 1 to 5 on embedded systems will be coordinated by Mrs. Ritula Thakur.
That's a contact mode.
That is a contact mode course, and 2 ICT mode courses, one from February 8 to 11 on energy management coordinated by Mrs. Shimi, and the third one is February 15 to 19 on soft computing and techniques coordinated by me. Okay?
Okay, madam. Thank you.
Okay, thank you.
Thank you, ma'am.
Thank you. Anybody else want to speak from Moradabad Institute?
No, ma'am. Thank you, ma'am.
Okay. Next, we'll go to IEC group of institutions. Connect me. PVP Siddhartha Institute of Technology, Vijayawada.
Hello, ma'am. Good afternoon, ma'am.
Good afternoon.
I'm audible to you, ma'am?
Yes.
Myself, I am C. Kumar, Associate Professor in Department of EEE. Regarding this program, all experts given good information for the such as distributed generation and hybrid vehicles and cyber security and hybrid PV and smart metering today, and all experts given good valuable and information. Some lectures also given with visuals. This is also very effective, and I would like to introduce our another faculty, Mr. M.V. Ramesh, will interact with you.
Yes.
I am Dr. M.V. Ramesh, Associate Professor. Regarding this course is very informative, and we could able to get new information regarding research, what we could able to do in future, especially in hybrid vehicles and also renewable energy sources. But one thing I would like to tell is this course is, I think this is very short, so we could not able to get full information. Maybe we can have a 2-week course also, so that we can have with more information and also practical exposure.
Okay.
Sir, your center was one of our nodal centers in one of my courses in either it was automation in industries or it was microprocessors. So I had a call from one of your faculty few days back that they had not received 2 certificates. So I want to know the status, if they have got or not. And in case they have not, please let me know the names of those 2 faculty so that I can start the procedure.
Which microprocessor?
Which department?
Either it was automation in industries during 5 to 8 or it was microprocessors and microcontrollers, because I had 2 alternative courses, so I don't remember exactly in which they were.
Okay, I will ask the coordinator of the knowledge center and I will let you know.
Yes. And here also, you please send the list of your participants, attendance, and your bills as soon as possible. On Monday itself, you process it and send it to me. To all the senders, I am saying, don't waste your time. Okay, as things become late, everything will be late. You send the list of your participants and the list of students who attended also separately.
Okay, ma'am. Okay, ma'am. By post or scanned copy, ma'am?
By post you sent. Scanned copy bills will not work. Now original bills we require.
Okay.
Anybody else want to give any feedback from PVP Siddhartha Institute?
Yes, madam.
One more, my colleague Mohan is here.
Yes.
Good afternoon, madam.
Good afternoon.
I am from PVP Siddhartha, assistant professor. So, madam, regarding this concept, distributed generation and about smart grid, microgrid, okay, all these concepts are very interactive and very much needed in these days. Why? Because the total complete energy 100% you take, so most of the energy we are using from the thermal power plants, nearly 60%, and from the non-renewable energy sources we are using only 12%. But there is a very much need to increase that percentage, non-renewable energy sources. So very much. Why? Because we have to concern the environmental problems, and economic wise also very important in order to increase these non-renewable energy sources, so mainly solar, wind. So we have to look at that, and so many, I am frankly telling, so many of, okay, they don't know what is actually the difference between microgrid, how smart grid works, and what is the main concepts, cyber security, software which are used for the smart grid and all. So people still need so much of details regarding those. If
Areas.
possible, try to conduct, as my colleague already said, within these 3 days we are not able to understand complete topics. If we arrange another things about the smart grids only in elaborate way, we can understand very much about this program. Thank you, madam.
Thank you.
Okay, thank you. Thank you for your suggestion. Anybody else want to speak from PVP Siddhartha, Vijayawada?
No more, madam. No more, madam. Thank you very much.
Thank you very much. Next, RD Engineering College. RD Engineering College.
Yes, ma'am.
Yes.
I feel the context of the course was very good, but I also feel that you could have gone more in depth. Like your wind power energy lecture, it was quite good, but unfortunately the servers weren't working. But he was giving the lecture more in depth. I feel like in cryptography, you could have told what are the different ways we could encrypt the information.
Yes.
So the lecture could have been more in depth.
Uh,
I lacked that.
Any other area?
Yeah, ma'am. One thing we also want that you will give more lectures on electronics and engineering. So embedded system like sorry,
electronics
and communication (EC). We would like to have more lectures on PLC like SCADA, on computer science.
Okay. See, we are from the electrical engineering department of the institute. There are different departments of computer science engineering and electronics engineering, also electronics and communication engineering also in this institute, and we have an operational plan of the year. So when you go to the nitterchd.ac.in our site, you will find the all courses which are given in the ICT mode, in electronics engineering and in computer science engineering. So you can go into it and then contact the respective coordinators. You have the numbers and all in the website. You can coordinate with them and then you can attend those courses, because
no, sir, but we have interdisciplinary courses also, like you said, embedded system, PLC, SCADA. We already had those ICT based courses. I think you skipped them. In September,
we have courses.
We had advanced microprocessors, microcontrollers, and their application course. It was ICT based. And again, in 5 to 9 October, we had an automation in industries in which we covered PLC, SCADA, and all topics which you are saying. In our department also we cover in such. You can see these courses under interdisciplinary
courses also. So you can
attend.
So you can attend those courses. ICT mode.
College, so they were one of our nodal centers.
Nodal centers only. You have been our nodal centers for almost. They have not attended. Otherwise we run courses. If you want to attend specifically, you look into it and then see the timings and then attend. You can call, if you are student sitting over there, you can contact your teachers and attend the classes. Okay.
Okay. I would love to say this is a great initiative you have taken, and congrats for that. Yeah, thank you, ma'am.
Okay. Now IEC group of institutions. नहीं बेटा. IEC group of institutions, Greater Noida. Professor Naruka. Yes.
Yeah. Hello. Hello.
Yes. Yes. We can hear you.
Good afternoon, ma'am.
Yeah. Good afternoon.
Good afternoon to one and all. Firstly, I would like to thanks IEEER Chandigarh for considering our request for this wonderful short-term course on smart grid. The course was very interactive and innovative. I am also thankful to all the participants and the speaker for this short-term course. Now I would like to call our respected head, Professor Sunil Kumar, for his valuable feedback. He is our chief guest also. Our director is busy in convocation in university. So I would like to call Professor Sunil.
Hello. Good afternoon to all.
Good afternoon, sir.
Good afternoon.
Today my director has gone to Lucknow in meeting. So on behalf of myself and a group of institutions, I would like to convey my sincere thanks to NITTR Chandigarh for giving us opportunity for participating in the short-term course on smart grid and renewable resources. I would like to convey my sincere thanks to all esteemed professors, especially Dr. J. Ernest, Dr. Lini Matthews, Dr. Mukesh Singh, who delivered very informative lectures and concept of new technology. Those who delivered the lectures, with these lectures, our all faculty members and students were participated and all were impressed with this courses. I would like to convey my special thanks to Dr. Lini Matthews, who is instrumental for designing our informative courses and engaging young professors for this course.
Okay, thank you.
Thanking you again for such type of courses in future also.
Okay.
One faculty of other institute also wants to give the feedback about these courses.
Yes.
Professor Atul Kumar.
Yes. Hello.
Yes, good afternoon to all of you.
Good afternoon.
Yeah, I'm Atul Kumar from MIT University Greater campus, and I'm very thankful to attend this short-term course on smart grid and such innovative technologies, and for the knowledgeable this course. And this short-term course is very thankful to all the faculties who are respecting in the domains and the research areas like smart grid and power system operation and control. And thanks again. Yeah, and, one more faculty and from IC College of Engineering and Technology also thankful and convey some ideas to you and feedback. Hello.
Hello. Hello.
Yes.
Yes.
Hello.
Yes.
Am I?
Yes. You are audible.
Yeah, I'm Mohammad Alamgir Khan from the Department of Electronics and Instrumentation Engineering. As we have gone through different lectures, presentations on power system stability, microgrid, smart grid, wind energy, and the most interesting according to me is hybrid electric vehicles. All lecture presentations are very interesting and impressive. I am very thankful to all the speakers and especially thanks to the organizing institute, that is NITTR Chandigarh. And thank you all the staff of NITTR Chandigarh and organizing committee and for organizing such a great program, knowledge sharing program. Thank you so much.
Thank you. Welcome.
Ma'am, one of our students also wants to share some feedback.
Yes.
Good afternoon, ma'am.
Good afternoon.
Hello.
Hello. I can hear you.
I am a student of electrical engineering final year.
Yes.
Hello.
Yes.
We can hear you.
Ma'am, short-term course being organized by IDENTIFIER was very inspiring for us. The lecture delivered by professors, especially on power system stability, hybrid electric vehicles, and renewable energy, was very helpful for us. And awareness of latest technologies and in research in electrical engineering. The course also helped us in my project ideas. The knowledge gained by us is quite practical in nature and rarely found in any books. I am thankful to you and our college for giving us such opportunity and wish to attend these kind of courses in the near future.
Okay.
Thank you, ma'am.
Thank you. Okay.
Okay, again, thank you. Thanks a lot, ma'am, for giving this opportunity to our institute. In future, we will connect definitely through this ICT program or the contact note program.
Yes.
Thank you, ma'am.
Thank you very much. Thank you very much. Okay, thank you, Professor Naruka. Now we'll go to Rajasthan Technical University, Dr. Lalwani. Hello, Rajasthan Technical University.
After you.
After you.
Hello.
Hello.
Hello. Can you hear me, madam?
Yes, yes, we can hear you.
I am Dr. S.R. Kapoor. I am one of the coordinators.
Yes.
I express my deep gratitude to NITTR and especially the Department of Electrical Engineering for conducting such a good short-term course. We at RTU feel privileged to be a part of this short-term program. Sessions, particularly the ones on solar energy, wind energy, then smart grid and cyber security were broadly appreciated. I invite our HOD, Professor Dinesh Birla, for his kind words. Professor Birla.
Good afternoon, ma'am.
Yes.
I'm Professor Dinesh Birla, head of the department, and it was really very good and it was a happy occasion that all the participants in this course from RTU Center as faculty members from engineering colleges, polytechnic colleges, some research scholars got this very good opportunity to have the ideas and the knowledge from the knowledgeable speakers from NITTR Chandigarh.
Okay.
I am grateful to your team for one other reason also, madam, that your knowledgeable lectures, knowledgeable speakers, the kind of the latest expertise and the kind of the knowledge which you have been transmitting to various centers. This center is fortunate that our research scholars, our faculty members who have completed their PhD, and they will get great deal to advance their research work further. This will be a real booster, and we hope that NITTR will continue to provide this kind of support to us so that our faculty and research scholars can get the knowledge and how to proceed towards their research.
Okay.
I understand I have amply expressed the feelings of our participants, and this is not my own feeling, this is the participant feeling which I wish to convey you. Thank you.
Thank you. Thank you. Anybody else want to speak?
Madam, the course modules which were presented were very relevant and of high quality, and all the participants, they have appreciated them, and we would look forward to
Rajasthan Technical
get association with you in future also. And ma'am, I must congratulate you for leading from the front by setting examples. Your able team has been really, we can understand you must be quite busy, not only in arranging the administrative facilities, in making sure that the telecast goes live all through, but also we can understand that you must have been putting a lot of effort in other areas also to make this program successful. Thank you, ma'am.
Thank you. Thank you. Okay. I think all centers are covered, na?
Modi has given their feedback.
Okay, now I think we have, I have heard from almost all these centers. Modi University had given their feedback before lunch. I have heard from them before lunch itself. So now we have a participant here. He also wants to speak about the course.
my only suggestion to Lindini ma'am and Sindhi ma'am is the course module, if it could be provided on the site as well, along with the STC courses, because we can go through the entire schedule that we have for STC courses. But the two tabs that are provided there, view and apply. We cannot get the what the crux of the course, entire course.
No, I think
we have a brief description.
Briefly, not the timetable. Like mainly briefly, what are the topics covered? It is there.
Contents of the course
Every course
is
it is there.
there.
I think.
No,
for applying, it is a different place. Apart from that, that is like you're going in applying. Apart from that, there is another portion where STCs like they give all the details. So that you might have missed. No, that the is main correct. objectives of the course and what we are going to cover in that topic. That is there.
Okay.
But the timetable, so we have to fix up an expert at the say a few days before because of the availability.
There was a suggestion from here that you before the course itself you should know the contents. See, in our website we have a portion where you can read through the contents, brief contents of the course before itself. So when we plan for the courses next year, we upload the brief contents and the course objectives of the courses also in the website. So before you apply, you can read through all the contents of the courses before itself, so that you can know what we are going to teach throughout the course. That will be a good thing before you apply for the various ICT courses. We have 3 different types of courses for each department. One is the interdisciplinary courses, next is the subject wise courses, and the ICT based courses. So you can apply for it. So the next year's plan has not yet prepared, that will come by April. So those which we have covered this year, some may be repeated next year also. So you can go through it, some may be changed, you can go through it and then apply for the next year also. So I congratulate and I thank all the participants and the coordinators from the nodal centers. I request Ritula Thakur to say a few words because she was not present in the inaugural function. I just wanted you to see the faculty members. We are the only 4 faculty members in this department. We coordinate various activities. So, but during the inauguration, Ritula had a class, so she could not come. So I give her some time to speak.
Thank you, ma'am, for giving me this opportunity. It was really a delight to listen to all the participants and their positive feedback, which was much anticipated since I know the kind of efforts our department puts into making all these ICTs a success. And I would also like to request all the nodal centers to kindly put in your feedback forms what kind of courses you want from us in the future, because that will help us in designing the O-plan for the next year. That's all I can say as of now. And congratulations, ma'am.
Thank you. Thank you. Let me stop now. You don't want to? Okay. One thing I want to tell to all the nodal centers is that again and again I'm telling you, you send the attendance, you send the list of participants, and send the bills also in time. And also the list of students who attended the course, the lectures, that also a separate sheet I require, that also you please send. So we conclude the course for this time. I have certificate for you. I will send all the certificates in time for all of you. So for that you have to send the list of your participants. Okay. Soft copy.
Okay, thank you, madam. Good day.
Thank you. Good day to all of you, and congratulations and goodbye. Good night. Okay.
Last lo biscuit